Hello there and welcome to our channel, where curiosity gets cozy and science takes the scenic route to slumber. Tonight, our quiet exploration drifts a little farther than usual toward a place you've seen many times without really seeing it. A soft point of light that rises before dawn or lingers after sunset, glowing steady and bright enough to cast shadows if you know where to look. You probably noticed it, maybe even wished on it once or twice, though it's not a star at all. It's Venus, Earth's sister world. And somewhere between that faint shimmer and the weight of your pillow tonight lies a question that's both impossible and irresistible. What if the first civilization in the solar system didn't rise on Earth, but on Venus long before we ever existed? Before we start wandering through that thought, I'd love to know where you're listening from this evening. Maybe you're tucked under a blanket. Maybe your room is quiet except for the hum of something familiar in the background. Maybe the night feels heavy and still. Or maybe you're half awake, somewhere the sun hasn't quite set yet. Wherever you are, we're connected right now by this small curiosity, by a gentle wondering about a world we've never touched. If you find this kind of slow science comforting, if it helps you drift or think a little differently before sleep, I'd be grateful if you gave the video a like or subscribe to this little corner of calm. It helps others find their way here too. Now close your eyes for a moment if you'd like, or let them rest on whatever dim light is nearby. Imagine looking up at the early morning sky before the sun breaks the horizon. There, just above the faint blush of dawn, is a planet so bright it's been mistaken for an approaching aircraft. A comet, even a divine sign. That light has fascinated humans since there were humans to notice it. It appears and disappears in cycles, sometimes as the morning star, sometimes as the evening star, never both at once, and always somehow more mysterious because of it. Venus is roughly the same size as Earth, only a little smaller. Its density and gravity are close to ours. So much so that scientists often call it our twin. But twins don't always grow up the same way. One became a world of oceans, forests, clouds, and breath. The other turned into a furnace wrapped in acid clouds and endless storms. Yet, when we look at Venus today through the haze and heat, we can't help but wonder what it was before it became this. What was hidden under those clouds before the surface melted into stone? Could it have been gentle once, blue once, alive once? Modern spacecraft have looked at Venus in ways our ancestors could only dream of, but even so, most of it remains hidden. The clouds are so thick they reflect most sunlight back into space, which is why the planet shines so brightly to us. Underneath that pale glow lies a world where temperatures can melt lead, where air pressure crushes anything made by human hands, where lightning flashes through clouds of sulfur and carbon dioxide. The first probes that landed there in the 1970s survived for minutes before failing. But before that harshness, before the long unbroken storms, evidence suggests that Venus may have been very different. Computer models show that billions of years ago, Venus could have had shallow oceans, mild sunlight, and a temperate atmosphere not unlike Earth's. The young sun was dimmer then, and the planet may have rotated slower or faster in ways that created a balance between warmth and cooling. Some researchers even believe that, for hundreds of millions of years, it might have supported liquid water on its surface. Water, as we know, is the essential ingredient for life. Where water lingers, chemistry becomes curious, and curiosity in nature often becomes complexity. It's not impossible that life began there. It's only impossible to prove it now. Imagine standing on that ancient Venus before the clouds thickened before the heat rose. The sky might have been a soft golden hue, perhaps tinged with faint pinks from minerals in the air. The sunlight would have felt slightly different, a little heavier, filtered through a denser atmosphere, but still bright enough to cast long ripples of shadow over smooth, shallow seas. Volcanoes dotted the horizon. But instead of being the relentless monsters they are today, they might have been part of a slow, breathing world, one with rivers and rainfall and the sound of distant thunder. If there had been life there, even primitive life, it would have had time to evolve to learn to build. On Earth, life appeared within a few 100 million years after the planet cooled. If Venus followed a similar path but began a little earlier, it could have had a long head start. Evolution doesn't follow a single script. It writes its own language out of chemistry and patience. Given enough time, enough stability, and enough curiosity from nature itself, something extraordinary could have happened. The idea of a civilization on Venus isn't new. In the early 20th century, before we knew what its surface was really like, scientists and writers often imagined it as a lush jungle world. They pictured vast rainforests, thick with alien vegetation and creatures shaped by endless warmth. Those images came from a time when telescopes showed only its brilliant clouds, leading people to think it was a paradise hidden under mist. Of course, we now know that the paradise was more like an oven. But the dream of a living Venus never really vanished. It just moved deeper into imagination. And sometimes imagination is where new science begins. If we entertain the thought that intelligent life once rose there, it opens a whole web of questions. What would they have looked like? These hypothetical beings of the first world. Would they have had forms adapted to dense air? Perhaps broader bodies to withstand pressure, maybe smooth skin to resist heat. Would they have built cities near the cooler highlands, where temperatures might have been bearable? Would they have known their sky was growing heavier, that something was changing slowly beyond their control? Our own history on Earth tells us that civilizations rise not only because of curiosity, but because of necessity. People gather to share resources, to manage the unpredictable, to build safety and meaning out of change. If life on Venus reached that stage, it must have faced challenges that pushed it to adapt. A changing climate, volcanic surges, chemical shifts in the atmosphere. Perhaps they studied their environment just as we study ours now. Perhaps they built instruments, recorded patterns, noticed the slow shift in heat and air. Maybe they even tried to stop it. Maybe they couldn't. Every world has a story of balance and loss. Venus, for reasons we're only beginning to piece together, lost its balance. A runaway greenhouse effect began, trapping more and more heat as carbon dioxide filled the atmosphere. Water evaporated. Hydrogen escaped into space, and the surface temperature climbed until oceans boiled and rock began to flow like soft wax. The sky became toxic. The clouds turned acidic, and the planet's surface redefined the meaning of uninhabitable. If anything alive had been there, even something as resilient as a microbe, it would have been erased. Still, the idea that a world could go from habitable to hostile is hauntingly relevant. It reminds us how fragile balance can be, how easily the ingredients that make life possible can shift toward destruction. When we look at Venus, we're not just looking at another planet. We're looking at a mirror tilted slightly toward the past, showing what might happen to any world that forgets how delicate climate truly is. You can almost imagine a time long before Earth's continents took shape, when Venus was the bright cradle of life in the solar system. Its people or its creatures, or whatever forms existed there, might have looked toward the sky and seen a faint blue dot. Earth still cooling, still waiting for its oceans to form. They might have wondered about it the way we wonder about them now, thinking of it as a possible home, a distant reflection, a place too young and cold to imagine life. Maybe they even dreamed of reaching it, not knowing that one day, billions of years later, beings on that very world would gaze back and ask the same questions about them. We can't know if such visitors ever existed, but traces of their world might still be out there. Venus occasionally ejects fragments into space during volcanic eruptions or asteroid impacts. Some of those pieces could, in theory, have drifted through the void, eventually landing on Earth as meteorites. If that happened, and if any biological material were preserved, a fossil molecule, a rare isotope, a pattern unlike any found here. It could be a whisper of that lost civilization, carried quietly across time. Scientists search for signs like that, though the odds are tiny. But the fact that the possibility exists at all is enough to keep the wandering alive. When we think about Venus today, we often picture its surface as a vision of apocalypse. But for scientists, it's also a treasure of knowledge. Every mission that studies it helps us understand our own planet better. The heat, the pressure, the chemical loops in its atmosphere are lessons in how climate can change beyond recovery. It teaches us about the thresholds we must never cross, the feedbacks we must respect, the fragile chemistry that keeps Earth livable. Yet beneath all that science, there's something more emotional, almost tender. Because when we look at Venus, we're not just studying a planet. We're remembering that worlds have fates and that we are part of one. We are the inheritors of conditions that could have been very different. We are living in the brief, gentle window where balance holds, where air is breathable and oceans stay where they belong. Venus might remind us that those things are not guaranteed. The thought that a civilization might have once thrived there and perished, leaving behind only silence, is heavy but strangely calming, too. It puts our own existence into perspective. Civilizations rise, planets shift, stars age, yet curiosity remains. The same curiosity that might have once made a Venusian look toward the night sky is the same impulse that makes us launch probes, build telescopes, and lie awake wondering who else might have looked back. Outside your window, Venus still shines when the sky is clear. It's always near the sun, never far from the horizon, always glowing just before morning or after evening. It's bright because its clouds reflect almost all the light that touches them, turning the planet into a mirror for the sun's fire. That mirror hides everything beneath, but it also keeps the mystery alive. When you see it, you're looking at a place that could have been the first home of consciousness in our solar system. You're seeing a ghost of possibility. Some nights, astronomers use radar to map the planet through its clouds, bouncing signals off the surface to reveal mountains, plains, and valleys. What they find looks both alien and familiar. There are volcanoes larger than any on Earth, plains that seem smoothed by ancient lava, ridges that might once have been shorelines. The landscape tells a story written in stone, a story of something that was lost slowly, not all at once. Each new map feels like opening an old photo album filled with images too damaged to recognize, but still precious. When you think about all this, about the chance that another world might have once carried the torch of life before us, it changes how the night sky feels. Every star becomes not just a light, but a potential story. Every planet a memory. Maybe life isn't something that began once in one place, but something that migrates, that learns, that restarts whenever it can. Maybe we're not the first civilization to ask where we came from, but simply the latest ones to wonder. Venus may never tell us its secret. Its clouds are too thick, its surface too hostile, its silence too complete. But even in that silence, there's meaning because the mystery keeps us looking up, keeps us curious, keeps us gentle in how we think about the universe. And maybe that's what the first civilization, if there ever was one, has left behind for us. Not ruins or relics, but curiosity itself, carried forward by sunlight and sleep, and the quiet persistence of wonder. And so we keep looking toward that soft, bright light in the sky, not for answers exactly, but for perspective. Somewhere behind those golden clouds lies the story of what might have been before Earth began its own. It's strange to think that a world so close to ours could feel so distant, yet still be part of our story. Part of the same sunlight that warms us now. The air you breathe, the warmth that touches your face, comes from the same star that once rose over that lost world. The connection is still there, waiting quietly behind the clouds. The night continues on its slow rhythm. And as Venus sets or rises wherever you are, that rhythm will continue, linking one world's memory to another's. And as we drift deeper into this exploration, there's still more to uncover about myth, about memory, about what the morning star has meant to those who have watched it for thousands of years. When people first began to look up at the early morning sky and give names to the lights they saw, one of the first they noticed was the one that rose brightest, closest to the dawn. It appeared with enough regularity to be familiar, but shifted just enough to feel alive, as if it had moods. Some mornings it was there before the sun, shimmering like a promise. Other evenings it lingered after sunset, trailing behind daylight like a secret that refused to fade. To those who watched carefully, it became a companion, a light that marked time and season and maybe even feeling. Long before telescopes, long before anyone could have known it was a planet, people saw Venus as a presence, something divine, something worth telling stories about. Nearly every civilization that learned to write the sky into story gave Venus a name that carried emotion. To the ancient Sumerians, it was Inanna, the goddess of love, fertility, and war, a paradox of creation and destruction wrapped into one brilliant light. The Babylonians called her Ishtar, the morning and evening star whose movements told of cycles of life and renewal. In Egypt, she was associated with the goddess Isis, the luminous companion to the sun god Ra. The Greeks saw her as Aphrodite, born from sea foam, radiant and untouchable, and the Romans borrowed the name unchanged, Venus, the goddess of beauty herself. In Mesoamerica, the Maya and Aztecs tracked her movements with astonishing precision. To them, Venus was a celestial timekeeper, a herald of change, sometimes an omen of conflict. When the planet rose just before dawn, priests would mark the event with rituals, believing it announced great shifts on Earth. The Chinese called it the Great White One, tie connected with purity and metal, a reflection of the planet's silvery brightness. And across cultures, she was both revered and feared, both gentle and powerful, both morning and evening. It's easy to forget that all these myths and stories came from the simple act of watching. For most of human history, the sky was our only reliable calendar, our only clock. People looked up not for escape, but for understanding. They noticed that Venus followed the sun closely, never straying far. That it vanished for periods before returning on the opposite horizon. That rhythm was hypnotic, repeating in cycles that matched the patterns of a rain, planting, and harvest. The connection between Earth's life and Venus's light became something almost instinctive. Even without knowing why, our ancestors sensed that the two worlds were linked. If we imagine for a moment that Venus had once been home to life, these ancient stories take on a different weight. It's tempting to think that the myths could be more than coincidence. That perhaps they echo a deep memory, something left behind, not in stone or bone, but in intuition. It's not a scientific claim, just a thought. If consciousness ever lived on Venus, if intelligence ever looked toward the sky and saw the faint blue dot of Earth rising and setting, maybe some fragment of that awareness carried forward. Maybe when humans later evolved on this world, something in us still recognized that light without knowing why. Venus's brilliance isn't an accident. It shines because its thick clouds reflect sunlight almost perfectly. Those clouds are made of sulfuric acid droplets suspended in carbon dioxide, turning the atmosphere into a vast swirling mirror. What we see from Earth is not the planet's surface, but its ceiling, an endless layer of brightness hiding everything below. In a way, that makes Venus the perfect symbol for mystery. It gives us light but denies us vision. It shows us presence without detail, beauty without clarity. For thousands of years, no one could pierce that veil. So imagination filled the space where knowledge couldn't go. Even as science replaced myth with measurement, Venus kept its mystique. Early astronomers like Galileo and Copernicus noticed that it showed phases like the moon, crescent, half gibbous. Proof that it orbited the sun, not Earth. This was revolutionary at the time, a small glowing argument against the idea that everything revolved around us. Later, telescopic observations revealed nothing more than a featureless disk always shrouded. No craters, no continents, no visible motion except its slow dance across the sky. It was a world hidden behind its own reflection. Before the space age, the best guesses about what lay beneath those clouds were optimistic. Some scientists imagined vast tropical oceans, thick forests, endless swamps under perpetual rain. Others pictured deserts dotted with strange towering plants, or seas teeming with amphibious creatures. The planet's brightness and proximity to the sun seemed to promise abundance. Even science fiction writers of the early 20th century built whole worlds there, with explorers wading through steaming jungles, encountering ancient ruins or alien intelligences. To them, Venus was the solar system's mirror image of Earth. Slightly more exotic, slightly more dangerous, but still alive. Then came the truth. The first radar observations in the mid-10th century bounced signals through the clouds and measured the echoes, revealing a surface hotter than any desert. With temperatures soaring above 450 degrees, the air pressure was more than 90 times that of Earth's, the equivalent of being nearly a kilometer underwater. Carbon dioxide dominated the atmosphere with only traces of nitrogen and virtually no oxygen. The paradise vanished, replaced by a nightmare of heat and acid rain. But even that discovery carried a strange kind of awe. It wasn't disappointment so much as astonishment that such a world could exist next door to ours. So similar in size, yet so utterly alien in condition. Despite its hostility, Venus still draws us. There's something magnetic about its contradictions. A planet of beauty and destruction. The brightest thing in the night sky, yet the most secretive. The same duality that ancient people saw in their goddess persists in our scientific understanding. Venus is both a warning and a wonder, a symbol of transformation, a reminder that appearances can deceive. The idea of an ancient civilization there might sound fanciful, but it isn't entirely without grounding in the broader story of planetary evolution. If early Venus had water and mild temperatures, it could have sustained microbial life. On Earth, microbes dominated for billions of years before anything complex appeared. If Venus followed a similar path, but evolved a bit faster due to its closeness to the Sun, there's a narrow window, perhaps hundreds of millions of years, when complexity might have flourished. In cosmic terms, that's not long, but it's enough. Given stability, evolution can move quickly. And if intelligence emerged, even briefly, its traces might be buried beneath kilometers of reformed rock. The surface of Venus is geologically young, only a few 100 million years old, likely renewed by massive volcanic resurfacing that erased older features. Whatever came before, if anything, is gone. But absence of evidence is not evidence of absence. It's just silence. And silence invites questions. When you think about how civilizations on Earth have risen and fallen, how entire cultures have vanished, leaving only fragments, clay tablets, carvings, ruins swallowed by forest. It's not impossible to imagine something similar happening on another world, multiplied by planetary catastrophe. A single cataclysm on Earth might topple cities or erase species. On Venus, the entire crust might have melted and reset, turning monuments into magma, records into vapor, memory into chemistry. The scale of loss would be absolute. And yet, for some reason, imagining that loss doesn't feel hopeless. It feels profound, like a reminder that creation and destruction are just different chapters in the same story. Across human myth, Venus is often tied to cycles. Love and loss, birth and death, morning and evening. That symmetry mirrors its orbit. The planet's year is shorter than Earth's, about 225 days, but its rotation is extraordinarily slow. A single day on Venus lasts longer than its year. The sun would rise in the west, crawl across the sky for months, and set in the east. The entire rhythm of existence there would have felt stretched, elongated, patient. If anything lived there, its sense of time would have been utterly different. Growth, movement, communication, all shaped by a world where the days themselves seemed eternal. Maybe that's why in myth, Venus is associated with endurance and rebirth. For astronomers, studying Venus is like looking into a possible alternate history for Earth. Two planets start alike. Same ingredients, same early warmth, but one slips into a feedback loop of heat while the other maintains balance. The difference may have been as small as a few percent of solar radiation, or the presence of a magnetic field strong enough to protect water from evaporating. Tiny cosmic coincidences determined which planet stayed alive and which burned. That contrast gives weight to our own story. It reminds us that habitability is fragile, not a guarantee, but a gift. If you step outside on a clear night and look toward the west just after sunset, you'll see that unmistakable glow. It's bright enough to twinkle faintly through thin clouds. Some evenings, it's so luminous that you can spot it even before the sky darkens completely. Astronomers call it a magnitude of -4. The brightest object in the sky after the moon and sun. Ancient travelers used it for navigation long before compasses, marking direction and season. Its reliability became a comfort, a symbol of continuity. And perhaps that's part of why it still draws our gaze. Despite all we know, the heat, the pressure, the acid clouds, Venus remains visually serene. It reminds us that even harshness, there can be beauty. There's an odd kind of peace in thinking about all the civilizations that have watched that same light, separated by thousands of years, united by the simple act of looking up. The shepherd in Mesopotamia, the priest in Egypt, the sailor in Greece, the astronomer in China all saw the same shimmer. All gave it a name. All wondered about it. The constancy of Venus's presence across time feels like a quiet thread connecting humanity to the deep rhythms of the cosmos. If an earlier civilization had existed on that planet itself, then the thread stretches even farther beyond human memory, into planetary history. The light we see would not just be a reminder of beauty, but of inheritance, of something that came before and is still shining, even if only as reflected sunlight. Today, spacecraft orbit Venus again. NASA and the European Space Agency have sent missions that map its surface with radar and sample its atmosphere. They've detected unexpected chemistry, traces of compounds like phosphine that are difficult to explain without invoking life, though other explanations exist. The debate continues, quietly persistent, fueled by the same curiosity that once made ancient astronomers draw Venus's path across the sky. It seems that even now, after all our progress, we're still asking the same question in more sophisticated ways. What is this light? What does it mean? Are we alone in the glow of it, or part of something older than we think? If you close your eyes now and picture Venus, try not to see the furnace that science has shown us, but the symbol it's always been. Think of it as a story told by light. A story that began long before Earth had cities, before language, maybe even before Earth itself was ready for life. That light has crossed centuries and minds carrying different meanings, but always the same quiet fascination. It has been a goddess, a sign, a beacon, a warning, and a mystery. It still is all of those things. As you breathe, as the world outside your window shifts between night and morning, that same light is moving across the sky somewhere, marking another cycle. It has done so for billions of years, long enough for planets to change, for species to rise and fall, for myths to be born and rewritten. And still it shines, steady and indifferent, yet strangely comforting. It's the same light that might have once risen over oceans of another world, reflected in the eyes of beings we'll never know, whose stories, if they ever had any, have dissolved into cloud and heat and silence. But silence, too, can speak. Venus has always spoken through reflection, through the quiet persistence of light. It doesn't tell us what it was, only what it is. And in that restraint lies its power. We fill the silence with questions, with myths, with science, with wonder. And in doing so, we become part of its story. Earth's children looking back at an older sibling, trying to remember what was forgotten. The morning star rises again and again, and every time it does, we begin the same ritual. We look, we imagine, we measure, we dream. Maybe that's the real inheritance from any civilization that might have once existed there. The act of wondering itself, the ability to look at a distant light and feel both curiosity and peace. As the story continues, the clouds of Venus will begin to part, not in reality, but in imagination, revealing what that lost world might have truly been like when oceans shimmered under a gentler sun, and the first sparks of life began to stir. And through that vision, we keep moving one thought to the next, letting curiosity lead the way deeper into the clouds, where memory and science blend, where the forgotten world begins to take form. When we think about Venus, what usually comes to mind are its clouds. They are its most defining feature. The reason it gleams so brightly, the reason its surface has remained hidden for so long. Even through powerful telescopes, all we see is that smooth, luminous veil. The clouds have become the planet's face, its identity, a mask of light that hides an entirely different world underneath. For centuries, that mask fooled us, suggesting comfort and warmth when in truth it guarded storms and fire. But behind those clouds, there is more than destruction. There is history written in layers of gas and heat, a record of change preserved in the chemistry of the air itself. The atmosphere of Venus is immense. It extends far higher than Earth's and behaves like a living thing in constant motion. The upper layers move with fierce winds, circling the planet in just 4 Earth days, while the planet below spins so slowly that a single day lasts more than a year. This strange mismatch between surface and sky creates a deep tension, almost as if the air and the ground belong to different worlds. At certain altitudes, the atmosphere moves so fast it breaks the rules of what should be possible. Winds can reach hundreds of kilometers per hour. Yet deeper down near the surface, the air thickens into something more like fluid. It presses with such weight that even sound would move differently, slower, distorted. For a long time, we couldn't measure any of this directly. When the first probes descended through the clouds, scientists held their breath, not knowing what to expect. The Soviet Veneer missions of the 1960s and 70s were the pioneers. Each spacecraft had to push through layers of gas that grew hotter and denser the deeper it went. The descent took about an hour. During that time, the instruments transmitted what must have seemed like a slow-motion fall through another planet's memory. Temperature readings climbed steadily. Pressure increased. The light outside dimmed to an orange haze. The radio signals became weaker with every kilometer. Then came the last transmission, usually just a few minutes of data from the surface describing rocks, heat, and silence. After that, nothing. Each probe ended the same way. A short burst of information, followed by the quiet static of failure. Still, from those few minutes of survival, we learned more than we ever had before. The surface was not made of oceans and jungles, but basalt plains and lava domes. The sky wasn't blue or green, but the color of rust. The clouds weren't water vapor, but sulfuric acid suspended in carbon dioxide. It was a world of extremes. And yet, every measurement, every image carried a strange familiarity. The rocks looked like rocks you might find in a volcanic desert on Earth. The plains stretched like dry lake beds. The horizon curved gently, softened by haze. Even in its alleyness, Venus felt connected, like a reflection seen through distortion. The clouds themselves are not uniform. They form layers, each with its own character. The highest clouds, about 70 km above the surface, are thin and wispy, made of small acid droplets that scatter sunlight evenly. Beneath them lies a thicker, more turbulent region, dense enough to trap heat and lightning. Deeper still, the air becomes so opaque that no light escapes. Temperatures rise sharply there, turning the lower atmosphere into a kind of slow cooking cauldron where gases mix and churn endlessly. Some scientists describe it as the planet's memory, a record of its ancient transformation. If Venus once had water, it would have evaporated into those layers long ago. Traces of it remain only as faint chemical ghosts. Hydrogen atoms that escaped into space, oxygen bound into rock, and sulfur left behind to form acid clouds. These layers are like pages in a book we can't quite open. Each one tells part of the story of how the planet changed from possible to impossible. High above the surface, in the region where the temperature and pressure are surprisingly close to Earth's, some scientists have found clues that raise new questions. There are mysterious patterns in the light that passes through the clouds, spectral fingerprints that don't match any known chemical combination. Some researchers once suggested that the anomaly could be due to simple processes we don't yet understand. Others quietly wondered if it could hint at something living, something microscopic drifting in the upper atmosphere where conditions are milder. The idea sounds bold, but it isn't impossible. Microbes on Earth thrive in acid, survive in boiling springs, float in the stratosphere, and persist in clouds for long periods. If life ever began on Venus when it was cooler and wetter, some of it might have migrated upward as the surface grew deadly, finding refuge in the thinner air. We don't know if that's true. The evidence is uncertain, the data incomplete. But the fact that we can ask the question at all shows how much we've learned since those first probes burned away. The next generation of missions already being planned will return with better tools designed to hover in the atmosphere for months, sampling gases and dust, listening to the planet's thunder. They'll look not for life as we know it, but for patterns, ratios, imbalances, the quiet chemical footprints that living systems tend to leave behind. It may be that the clouds themselves hold the last traces of Venus's biological past, mixed into their swirls like faint perfume long after the source is gone. If you think about those clouds long enough, they begin to sound less like a barrier and more like a record. They've witnessed everything. When Venus was young, they might have been thin and soft, more like the high cirrus clouds we know here. As volcanic activity increased, they thickened, reflecting more sunlight, trapping more heat, and feeding the loop that would eventually transform the planet. Each eruption, each chemical shift added new layers. Over billions of years, those layers turned the planet into what it is now, a bright, opaque world that remembers but does not reveal. Even with all our technology, we've barely scratched its surface. Radar mapping from orbit has shown that much of the planet is covered in vast plains of hardened lava, punctuated by domes and ridges. There are mountains too, some rising higher than Everest. The tallest, Maxwell Montes, lies near the planet's north pole, and its slopes appear to be covered with something that reflects radar differently than the surrounding rock. Scientists once joked that it might be metallic frost, though it's more likely to be mineral deposits that condense from the atmosphere. Still, the image is striking. Mountains glinting faintly under a heavy orange sky, hidden forever beneath clouds. It's almost impossible to imagine what standing there would feel like. The air would be so thick you could almost swim through it, and the heat would press against every surface. The light would be dim, golden, filtered through haze. The horizon would seem closer because the dense air bends it upward, distorting distance. The ground underfoot would be baked rock, fractured and dusty, shaped by slow geological tides. If there were once oceans, they'd be gone. Their beds turned into plains of volcanic glass. Yet even in that silence, there's a sense of story. Every rock, every chemical trace holds a fragment of what came before. Water that boiled away. Carbon that once cycled through living systems. Minerals that crystallized as the last seas vanished. Venus reminds us that worlds can change not just slowly, but completely. On Earth, change happens within boundaries. Ice ages come and go, continents drift, climates warm and cool, but the core conditions remain stable enough for life to continue. On Venus, the balance tipped so far that the entire system reset. It became a new kind of planet, one that no longer supported the chemistry of life. Studying that transformation helps us understand what stability really means. How delicate the thresholds are that separate a living world from a dead one. There's something almost intimate about the way the planet hides itself. Unlike Mars, which shows its surface openly to any telescope, Venus keeps its secrets close. We only know it through indirect observation, through light that bounces, through heat that leaks, through radio waves that echo back. It's as if we're piecing together someone's memory from fragments of conversation. That's why every new mission feels like an act of listening. We send signals. They return faintly altered. And from those echoes, we reconstruct a story. One of the more fascinating aspects of Venus's clouds is how dynamic they are. Images taken by orbiting spacecraft show vast patterns moving across the planet, waves and vortices the size of continents. Near the poles, the clouds twist into double spirals, a constant storm that has raged for centuries. These structures shift and evolve, driven by heat from below and winds from above. They're not static at all. The planet's atmosphere is alive in a way its surface no longer is. And that movement, that constant circulation acts as a reminder that even in extremes, systems find a way to keep going. When we model Venus's past using supercomputers, the results are both haunting and hopeful. Under the right conditions, the planet could have maintained liquid water for as long as 2 billion years. That's nearly half the age of our solar system. In that time, simple life could have arisen, adapted, and perhaps even built something we might recognize as culture. If that happened, those beings would have lived under skis that gradually thickened, watching their world change in ways they couldn't stop. The end wouldn't have come suddenly, but as a slow warming, a rising sea of heat and gas that crept higher each generation. They might have looked upward through the brightening clouds and noticed their sun growing harsher, their horizon growing hazier. The transformation would have been slow enough to record, to study, maybe even to mourn. When we look at Venus now, we are seeing the after image of that process. The clouds are what remain of that long unraveling, frozen in chemical equilibrium. They show us what happens when a planet loses control of its own climate. The feedback loops that once stabilized it have broken, replaced by runaway reactions that feed themselves. Carbon dioxide traps heat. Heat releases more gas. And the cycle never ends. It's a sobering mirror for us. A glimpse of one possible future if we're not careful with our own thin atmosphere. And yet, despite its danger, there's beauty in the system's completeness. Venus is not chaotic. It's balanced in its own harsh way. The temperature, the pressure, the composition, all stable now, unchanging for millions of years. In its permanence, there's a strange serenity. The planet has reached its equilibrium, even if that equilibrium is hostile to life. Sometimes balance itself is indifferent. Thinking about the clouds this way, as both the planet's protection and its prison, gives them a symbolic quality that's hard to ignore. They preserve what's left of Venus's story, keeping it safe from view, but not from imagination. When spacecraft fly by, they capture images of light reflecting off those layers, soft gradients of cream, yellow, and gold. The patterns shift slowly, hypnotically, like currents in a painted sea. The movement feels almost alive. In those moments, when you watch time-lapse footage of Venus's atmosphere, you can forget that what you're seeing are storms of acid at hundreds of degrees. All you notice is motion, graceful and continuous like breathing. It's possible that within those clouds lie the last remnants of the planet's memory of life. Not in the form of fossils or ruins, but in chemistry. In the balance of elements that once supported something living. Perhaps that's what makes Venus so compelling. It's not just a world we study for data. It's a world that reminds us of fragility, of change, of how easily the familiar can become alien. As we continue to explore it mission by mission, the clouds remain both obstacle and invitation. They obscure the surface but invite imagination. They block our view but reflect our curiosity back at us. Through them, we learn patience. Through them, we remember that understanding takes time. That discovery often begins in uncertainty. And so the story continues not with answers, but with the quiet persistence of inquiry. The clouds will keep their secrets a little longer, but we'll keep asking because somewhere behind that brightness lies the next step in this long imagining. The world that once might have been blue before the heat, before the silence, when Venus and Earth were still young and not yet strangers under the same sun. When scientists talk about Venus as it is today, the conversation usually turns quickly to heat, acid, and pressure. It's easy to think of it as a planet defined by extremes. A place where nothing soft could ever exist. But before that harsh world took shape, there was another Venus. Quieter, cooler, younger, a version that may have been blue. For a long time, the idea that Venus could have had oceans was pure speculation. There were hints in its composition, clues in its density, faint traces of lost water vapor in the atmosphere, but they didn't form a clear picture until computers became powerful enough to simulate entire worlds. When researchers began to model the planet's early climate, something remarkable appeared. Under certain conditions, especially when the young sun was dimmer and the rotation of Venus slower than it is now, the planet could have supported liquid water on its surface. Not for a brief moment, not for a few centuries, but for hundreds of millions of years, long enough for weather, erosion, even perhaps life. It's strange to imagine Venus not as the golden mirror we see today, but as a place of clouds like ours, a world with rain and sea breeze and reflections of sky on open water. In those models, the planet's surface temperature stabilizes at levels familiar to us, mild, even temperate. The key lies in the delicate dance between sunlight, atmosphere, and rotation. Venus rotates very slowly, taking about 243 Earth days to turn once on its axis. That means the same side can face the sun for months at a time, while the other side rests in darkness. If it rotated a little faster in its early history, the balance between day and night could have been gentler. Clouds would have formed on the sunlit side, shading the planet and keeping it cool. Rain would have fallen, feeding rivers that cut through volcanic plains. Oceans would have spread across low basins, shimmering under a soft golden sky. At that time, Earth would have been young, its crust still shifting, its surface struck often by asteroids. Venus, slightly close to the sun, might have cooled first. It could have been the first truly habitable planet in the solar system. While Earth waited for its climate to settle, Venus might already have had shallow seas, continents, and a stable atmosphere rich in nitrogen and carbon dioxide in workable amounts. If any planet had the head start for life, it was that one. What would it have looked like from space? Perhaps much like Earth, white clouds swirling over blue oceans, continents tinged with red and gold. From orbit, the two worlds would have seemed like twins indeed, separated by only a few million km, each bathed in the same sunlight, each capable of supporting chemistry that breathes and evolves. The difference between them would have been subtle, hidden in the balance of water, air, and heat. But over time, small differences in that balance can grow into fate. On Earth, water acts as a thermostat. It absorbs heat and releases it slowly, keeping temperature steady. On Venus, that thermostat may have worked for a long time. Rain would have fallen, evaporated, formed clouds, and fallen again in a stable cycle. Volcanic eruptions would have released gases, and the oceans would have absorbed some of them. The system might have held equilibrium for ages. Then something changed. The sun grew brighter as stars do with age, increasing the amount of energy reaching Venus. The oceans began to evaporate more quickly. Water vapor itself, a greenhouse gas, trapped even more heat. The surface warmed, evaporation accelerated, and the cycle began to spiral. The balance that had lasted for eons started to slip. Scientists call this process the runaway greenhouse effect. It's not a sudden catastrophe, but a slow, relentless transformation. As temperatures rose, more water entered the atmosphere. High-energy sunlight broke those water molecules apart, letting hydrogen escape into space while oxygen bound with rocks. The seas retreated into the air, then vanished entirely. The planet lost its water, its most precious regulator, and the carbon dioxide released from the crust built an atmosphere that trapped even more heat. Within a few 100 million years, the surface became unrecognizable. Oceans turned to steam and steam to acid clouds. The air thickened until it pressed like the weight of an ocean, and the planet's skin cracked under the strain. When we look at Venus now, we see the end of that story. A dry, shining sphere wrapped in haze. But knowing what it once might have been changes how we see it. It's not just a dead world. It's a world that lived. A planet that crossed a line it could never return from. In that sense, it's a cautionary mirror. It shows us how small the margins can be between life and loss. The question that lingers is whether life began there before the transformation. On Earth, microbial life appeared surprisingly quickly once conditions were stable enough. If the same rules applied on Venus, and if its oceans lasted long enough, life could have taken hold. Perhaps it began in warm shallows, feeding on minerals leached from volcanic rock. Perhaps it floated in the upper layers of early seas, forming colonies that photosynthesized faint sunlight through thick air. If that happened, there's a possibility, distant but real, that those organisms left traces behind. We might never find fossils on Venus. The surface has been resurfaced too many times by lava, but the atmosphere still carries hints. Tiny amounts of deuterium, a heavier form of hydrogen, remain far more abundant on Venus than on Earth. That ratio tells a story. It suggests that vast amounts of lighter hydrogen once escaped into space, likely from evaporating water. The numbers fit with the idea of oceans lost to time. The chemistry of the rocks revealed through radar and spectroscopy supports it, too. Certain minerals there can only form in the presence of water. They are the fingerprints of a world that once had rain. Even the topography offers clues. Radar mapping shows features that look like river valleys, plains that could have been ancient seafloors, and highlands that resemble continents. It's as if the planet remembers in the shape of its body, the touch of water long gone. These are only interpretations, but they hint at a geography shaped not just by fire but by flow. Imagining a blue Venus is more than romantic speculation. It's an exercise in understanding planetary evolution. It helps scientists test their models of climate, geology, and atmosphere. If we can reconstruct how Venus turned from mild to molten, we can better understand what keeps Earth balanced. That knowledge is not abstract. It's a guide for our own survival. Venus may have been the first planet to test what happens when carbon dioxide dominates an atmosphere. It failed the test. We can still learn from its mistake. But beyond the science, there's something deeply human about thinking of Venus as it might have been. It's not just a lesson in climate or physics. It's a reminder that even planets have histories, that they grow and age and change like living things. 1 billion years ago, Venus might have been a gentle world under soft sunlight. Then slowly it drifted into fever. When we study its clouds and heat today, we're not just seeing a foreign place. We're looking at the memory of a world that once breathed. If you could stand on the shores of that early Venus before the heat rose, before the seas began to boil, you might see waves lapping against dark volcanic rock. The air would be thicker than ours. The sky muted gold. The light would feel heavy, but not unbearable. Winds would move slowly, brushing the surface like warm breath. There might be rain, soft and frequent, collecting in shallow pools that mirrored the slow-moving clouds above. Nights would come rarely, long and dim, with a faint red hue from the distant sun. It wouldn't have been an Earth-like paradise, but it would have been stable, alive in its own rhythm. Perhaps in those early days before life emerged, Venus looked up at Earth as a faint blue dot in its twilight sky, unaware that its sibling would one day inherit everything it was about to lose. The thought adds a quiet melancholy to our understanding of the solar system. Two worlds born from the same dust, warmed by the same star, set on diverging paths. One toward life, the other toward silence. When we build spacecraft to visit Venus, we're in a sense visiting our past. Every image, every data stream carries echoes of what might have been. The clouds, once white, now glow sulfur yellow. The air once filled with rain now carries acid mist. But the underlying structure of the planet, its mountains, plains, and ancient valleys, still whisper of oceans that once reflected sunlight. They are scars of memory not yet erased, just buried beneath heat and time. In studying that memory, scientists often speak with a kind of reverence. There's awe in realizing that a planet can change so completely. There's humility in seeing how thin the line is between habitability and ruin. And there's something profoundly moving in knowing that had events unfolded differently, we might be the descendants of that earlier world. The first civilization, if it ever existed, could have risen among those vanished seas. They might have watched their oceans retreat, their air grow thick, their world dim. They might have built, learned, hoped, and then vanished, leaving nothing but an echo in the chemistry of the sky. Some researchers even speculate that the seeds of life on Earth could have come from there. If impacts or volcanic eruptions ejected rocks into space, fragments carrying microbial life might have drifted across the narrow gap between worlds, falling into our oceans when Earth was still young. The idea called lithopanspermia is not proven, but it isn't impossible either. If true, then life on Earth could be a continuation of life that began elsewhere. Not alien in the distant sense, but familiar, ancestral. We could be, in a way, the children of Venus, inheritors of a world that no longer exists. It's difficult to confirm any of this, but that's not the point. The act of wondering keeps the search alive. Each new mission, each improved simulation, each chemical analysis brings us closer to understanding what really happened there. And in that pursuit, Venus ceases to be just a symbol of failure. It becomes a teacher. When sunlight hits its cloud tops, it reflects almost entirely, sending brilliance outward. That brightness is what we see from Earth. The reason it's the first star to appear at dusk. But beneath that brilliance is the story of balance lost. The same sunlight that once made its oceans sparkle eventually burned them away. The same warmth that once sustained life consumed it. It's a paradox. Light and loss, inseparable beauty built on catastrophe. Even so, there's something comforting in the idea that planets have phases, just as stars and life do. They begin, they change, they settle. The blue Venus of the past might have been as alive and vibrant as our own world is now. The Venus we see today is the elder version, weathered and reflective, bearing the marks of its long history. In its silence, there's endurance. The planet has stabilized, found its harsh equilibrium, and continues to orbit faithfully, shining through every dawn. If you ever watch it rising in the morning sky, you're seeing both the present and the past, the furnace and the ocean, the loss and the memory. That light has crossed billions of years to reach your eyes. It carries the reflection of what once was and the possibility of what could have been. It's a reminder that change is constant, that balance is delicate, and that even in loss, something remains. The persistence of light, the quiet endurance of a world that might once have been blue. And through that endurance, we move forward again deeper into imagining what followed when life may have touched that world, when sparks rose beneath a soft sky, and intelligence perhaps briefly found its place amid warmth and storm. If Venus truly was once a place of water and warmth, then at some moment long ago, something in those oceans must have stirred. Not the violent kind of stirring that comes from storms or tides, but the quiet one that begins in chemistry. Molecules met, combined, broke apart, and found each other again. Patterns formed. Energy moved through the water not just as heat, but as rhythm, as repetition. The smallest of processes began repeating themselves, and somewhere within that repetition, memory began. Not memory in the way we understand it, but the kind that nature itself uses to build life on Earth. That process happened more than 3 billion years ago. We don't know exactly how, only that it began in conditions where energy, water, and time worked together. Hydrothermal vents, tidal pools, lightning, and a dense atmosphere. All of these are possible birthplaces. Venus, if it once had oceans and a mild climate, would have offered the same ingredients, the same chemistry, the same spark. It's possible that life didn't just have a chance to appear there. It might have had a head start. The early Venusian seas, if they existed, would have been shallow in many places, spreading across broad plains of dark basalt. Volcanic activity was frequent, but not yet catastrophic. Carbon dioxide filled the air, but so did nitrogen and traces of water vapor, forming clouds that rained often and gently. Lightning would have flickered through the skies, feeding energy into the atmosphere, creating complex molecules. Every flash might have been a new experiment, a test of what could live. Beneath the surface, geothermal energy would have seeped through cracks in the crust, warming the water from below. Minerals dissolved into the ocean, reacting with carbon compounds drifting down from the air. It's a familiar story, one the Earth also told in its own way. If you could have drifted above that ancient Venus, perhaps you would have seen vast areas of soft, reflective water under a haze of golden clouds. The light would be different from Earth's, more diffuse, filtered through the thick atmosphere, but it would still shimmer. In that muted glow, photosynthetic chemistry might have evolved differently. Perhaps instead of green pigments, life on Venus used something else to capture sunlight. Something tuned to the filtered yellow and red wavelengths. The oceans could have glowed with faint color when the light changed, like a living mirror responding to the sun's warmth. Even if life there remained microscopic, it could have transformed the planet. Microbes breathe and feed and exhale, changing the chemistry of their world. On Earth, single-celled organisms filled the air with oxygen and shaped the environment for everything that came later. On Venus, similar processes could have occurred, though with different results. Instead of oxygen, maybe they release sulfur compounds or methane, feeding a unique atmospheric balance. If so, the traces of that biology might still be faintly written in the ratios of gases that remain today. The patterns we see, the unexplained chemistry, the presence of certain compounds in unexpected places, could be the fading echo of biological metabolism from billions of years ago. It's easy to think of life as something that either exists or doesn't. But reality is more gradual. Between the sterile and the living lies a wide region of potential, chemistry that almost thinks, almost feels, almost remembers. On Venus, that threshold may have been crossed early. Once it was, the rest would have followed naturally. Adaptation, variation, complexity. Given time, life doesn't need guidance. It explores every path available. For a long stretch of its history, Venus might have been stable enough for those paths to multiply. Species would have evolved to fit their environment, adapting to heat, to pressure, to light. In shallow seas, mats of microbial life could have spread across rocks, forming colonies that trapped sediment and shaped the surface. In deeper water, strange organisms might have drifted, feeding on the chemical gradients rising from volcanic vents. Every world with water becomes a laboratory, and Venus had all the ingredients. When we look at the surface of Venus today, radar images show a world remade by volcanic activity. The entire crust appears relatively young, only a few 100 million years old, which means that sometime in its past, the planet experienced a massive resurfacing event. Lava flowed over much of the globe, erasing older features. For geologists, this is a clue to how Venus lost its water and became what it is. For dreamers is also a possible clue to what it once was. Because before that great eruption, before the crust renewed itself, there might have been continents, coastlines, and places where life gathered. If there ever was complex life on Venus, its last days would have been slow but certain. The sunlight would have grown stronger, the seas thicker, the oceans shallower, rain would have turned more acidic. Temperatures would have climbed gradually, then faster, as feedback loops accelerated. For generations, life might have adapted, evolving heat-resistant enzymes forming protective layers migrating toward cooler highlands. But there would come a point when adaptation couldn't keep up. The ocean surface would steam, leaving behind concentrated salts and minerals. The last shallow waters would recede into depressions. Organisms clinging to survival might have retreated underground or into the clouds, seeking refuge where conditions were still tolerable. It's not hard to imagine some of those life forms developing intelligence if the conditions lasted long enough. Evolution favors curiosity when it can afford it. On a world of slow rotation, where days and nights stretched for months, life would have moved in long rhythms. A single sunrise could last an entire lifetime for some creatures. Patience, not speed, would shape their thinking. If sentience arose, it might have come from beings adapted to heat, to light filtered through dense air, to gravity nearly the same as ours. They would have lived close to the sea, building with materials that could withstand constant moisture and pressure. They might have measured time not in hours or seasons, but in the slow drift of the clouds above them. We can only speculate what such a civilization might have looked like. Perhaps they studied the sky, noticed the faint blue shimmer of a younger Earth rising and setting on their horizon, wondered what it was. Perhaps they began to sense the changes in their own world, the slow drying of air, the thickening of clouds. They might have built instruments, recorded patterns, tried to understand the physics of their environment, the chemistry of their air. And maybe, just like us, they underestimated how fast the shift could come. If that civilization existed, its memory is gone now, melted into rock and gas. But the possibility that it once did changes the way we look at our own beginnings. What if intelligence didn't start on Earth at all, but began elsewhere and vanished, leaving us to pick up the thread? What if life itself has always been a migratory force, traveling from one habitable world to the next, adapting, restarting, carrying echoes of what came before? There's a scientific theory that supports the idea, at least in principle. It's called panspermia, the notion that life can travel between planets on meteorites, dust, or even in the upper layers of atmospheres. If Venus once had a thriving biosphere, impacts from asteroids could have ejected fragments of its surface into space. Some of those fragments might have reached Earth during its early stages, when our planet was cooling and forming oceans of its own. Inside those fragments, microorganisms could have survived, dormant but intact, protected from radiation by layers of rock. When they finally landed here, they would have found a world ready to receive them. Water, warmth, and opportunity. It's a small leap in imagination, but not in physics. Meteorites from Mars have been found on Earth. The same process could have happened from Venus, though its thick atmosphere makes it rarer. Even so, if just one piece made it through, carrying one viable organism, it would have been enough. If that happened, then we're not just Earth's children. We're descendants of a larger lineage, the continuation of something that began elsewhere, perhaps under the same sunlight, but in a different cradle. Venus, in that sense, would be not just our twin, but our ancestor. Its oceans would have been the first pages of the story that later unfolded here. The thought brings both wonder and humility. It suggests that life is resilient, that it doesn't depend on perfection, but only on persistence. It also suggests that loss and creation are intertwined. That one planet's end could be another's beginning. When Venus lost its seas, perhaps some of its life escaped, seeded across the solar system, waiting for new ground to take root. We may carry traces of that inheritance in our DNA. The chemical language of survival written long before Earth itself was ready for speech. Every time scientists study the upper atmosphere of Venus, they find surprises. Unusual patterns of light absorption, strange distributions of sulfur and chlorine compounds, hints of something dynamic that doesn't quite fit with what we expect from pure chemistry. In 2020, researchers announced they had detected phosphine, a molecule associated with biological processes on Earth. Though the result remains controversial. It might turn out to have a geological explanation, but even the possibility keeps the discussion alive. The fact that we're still unsure speaks volumes about how complex the planet is. Venus refuses to fit neatly into our categories of living or dead. It hovers between them, as if the boundary never completely closed. It's not easy to picture that world in detail, but if you try, you can imagine an entire planet moving through its own version of evolution. In its youth, calm seas under a pale gold sky. Later, denser clouds, warmer days, shorter nights. Then the long transition, evaporation, storms, lightning that never stopped, rain that turned corrosive, oceans that shrank into vapor. Through it all, life, if it existed, would have fought to adapt. The last survivors might have been microscopic forms floating in the clouds, carried endlessly by winds circling the globe. The idea of life living in the sky might sound poetic, but it's practical. On Earth, bacteria are found kilom above the surface, riding air currents. On Venus, the cloud tops are mild in temperature and pressure, almost Earth-like. There in that suspended layer, life could persist in exile unseen but enduring. Perhaps that's what remains of Venus's spark. Not a civilization, not even complex organisms, but a thin haze of microbial persistence, still floating, still metabolizing slowly under the perpetual storm. The planet might be dead on the ground, but alive in the air. If that's true, then life has proved something extraordinary, that it doesn't need comfort, only opportunity. It can find a way, even in places that seem impossible. The story of Venus's transformation from blue to gold to gray is not one of tragedy alone. It's a lesson in change. Planets evolve. Environments shift. The same sunlight that gives life its warmth also sets the limits of its endurance. If Venus began with life, it lost it not through violence, but through inevitability. Through the simple aging of its star, through the subtle imbalance of feedback loops that turn stable warmth into heat. It's a natural process, but one that feels personal because we too live in the thin margin where balance holds. The clouds of Venus still move with rhythm. Winds circle the planet faster than it rotates, creating global waves that ripple through the atmosphere. Lightning still flashes. Thunder rolls through air too dense to hear. And sunlight still filters softly through the haze. The sparks beneath that soft sky never really stopped. They just changed form from chemical to electric, from living to elemental. The planet still burns with energy, still glows faintly in infrared, still breathes heat into space. It may not have life as we define it, but it remains alive in motion, in physics, in persistence. And so as we drift further into its story, we begin to see how those sparks, whether biological or geological, connect to what came next. Because if there was once life on Venus, and if that life ever learned to think, to build, to dream, then somewhere between the first microbes and the last storms, consciousness would have awakened. Not ours, not human, but something aware enough to feel the warmth of its world fading and the weight of its sky growing heavy. Something that once looked at the horizon and saw beauty even as it changed. That thought leads us forward past the calm oceans and the lightning storms into the age when awareness itself may have taken root. When the architects of the first dawn looked up through the clouds and began to wonder, just as we do now, what their world meant and how long it would last. If life on Venus had endured long enough to think, then the first dawn of intelligence would have been slow, quiet, and deeply patient. Nothing about that world would have encouraged haste. Its days were too long, its air too heavy, its light too filtered to rush anything. Change came gradually there, measured not in hours or seasons, but in the turning of the clouds, in the slow shimmer of sunlight diffused through gold. A mind that formed under such skis would have understood time differently. It would have learned to wait. It would have built its world in rhythm with the planet's stillness, not against it. When we imagine intelligence beyond Earth, we often imagine motion, technology, and progress. The visible signs of thought made solid. But on Venus, the conditions for thought would have shaped something entirely different. There would have been no stars visible through those endless clouds, no clear night sky to inspire navigation or myth. Their world would have been enclosed, intimate, wrapped in atmosphere. The sun would not have blazed in the sky. It would have glowed softly, hidden, spreading a warm haze that changed slowly as the planet rotated. If a civilization rose there, it would not have been driven by exploration outward, but by exploration inward. It would have learned to read its own air, its own tides, its own chemical breath. On such a planet, perception itself would have been shaped by the environment. In the dense atmosphere, light scatters differently. Sound travels slowly, and color fades at short distances. Senses would have evolved to notice gradients, shifts in temperature, texture, vibration. Communication might not have depended on voice or light, but on movement, resonance, and subtle pressure. A civilization born in that world might have understood space less as emptiness and more as continuity. A constant medium through which everything connects. To them, air and matter would not have been separate. They would have felt the world as one continuous body, alive and whole. The architecture of such beings would have followed the same philosophy. Instead of sharp structures reaching toward a sky they couldn't see, they might have built downward, inward, harmonizing with the pressure of the air. Shelters carved from mineral foam or cooled volcanic glass. Domes sealed against acid chambers filled with carefully balanced air mixtures, not to isolate from the planet, but to shape it gently. Their buildings would not have been monuments of dominance, but of balance. They would have understood that stability required cooperation with their world, not defiance. If they mastered materials, they would have done so through chemistry, not combustion. Fire, as we know it, would have been impossible under such an atmosphere. There would be no flame in a sky so rich with carbon dioxide, no spark that could sustain itself. Energy would have been drawn instead from thermal gradients, from the planet's slow heat, from chemical reactions between minerals and air. Power for them would have meant patience, the steady harnessing of what was already present, never wasteful, never violent. The closest equivalent to our electricity might have been the planet's own lightning. Venus is a world of constant storms, and the flashes that pass through its clouds are massive, illuminating the sky from within. Perhaps they learned to capture that energy, to study it, to time it. The flicker of lightning could have been their first clock, their first measure of change in an otherwise timeless world. Maybe they watched those flashes the way early humans once watched fire, not just as danger, but as revelation. In their oceans, where light barely reached, life would have thrived on chemistry rather than sunlight. Communities of organisms might have clustered near geothermal vents, exchanging energy through mineral reactions. If intelligence began there, it might have emerged from cooperation among such colonies, networks of life communicating chemically long before language existed. That sense of connection could have persisted even after technology developed. Their science, if it evolved, would have been built not on separation and classification, but on integration, on understanding systems as unified processes. They would have looked at their planet not as a collection of objects, but as a single breathing system of atmosphere, water, and stone. When we imagine civilization, we often think of it as something visible from above. cities glowing in the night, roads, walls, geometry. But if their world was wrapped in permanent daylight, filtered through thick clouds, they would have lived in perpetual twilight. They might never have seen shadows. Their sense of direction would have come from wind, sound, and pressure, not light. Their maps, if they had any, might have been sonic or chemical, describing the movement of air and current, not the outline of land. They might have listened to their world the way we look at ours. And if they listened closely, they would have heard their planet changing. The first signs of imbalance might have appeared as shifts in the air. A steady warming, a thickening of the clouds, the disappearance of gentle rain replaced by harsher storms. Perhaps they recorded it in their own way. Perhaps they built instruments to measure it. Delicate sensors attuned to subtle differences in temperature and composition. Over generations, they would have realized that something irreversible was happening. The warmth that once fed life now threatened it. Faced with such change, their culture would have turned toward preservation. They might have tried to control the atmosphere, to cool the surface, to draw carbon back into rock. They would have experimented, perhaps building vast networks designed to restore equilibrium, reflecting clouds, absorbing gases, controlling volcanic flows. But the feedback loops on Venus are merciless. Once the runaway greenhouse began, there was no stopping it. Every success would have been temporary, every intervention undone by the planet's own chemistry. The more they tried, the faster the system might have responded. There's a tragic familiarity in that. The story sounds distant, but the shape of it mirrors our own. Intelligent beings recognizing that their world is warming, acting too late, discovering that even knowledge has limits when time runs short. Maybe they understood it not as punishment or failure, but as the natural conclusion of planetary life cycles. They might have faced their end not with panic, but with acceptance, turning their focus inward again toward memory, toward legacy. If their civilization reached such heights, they might have left behind records not written, but encoded chemically or geologically. Perhaps they learned to etch information into stable minerals, to store thought in crystal patterns resistant to heat. Those records could still exist, buried beneath the crust, waiting under kiln of basalt. We might have already seen them mistaken for natural formations. The idea is fanciful, but no more so than the notion that intelligence could evolve twice in one solar system. If life exists on one world, it can exist on another. The laws are the same, only the details change. Even if they never reached what we call technology, the evolution of intelligence itself would have reshaped the planet. A thinking species alters its environment by necessity, not always through machines, but through intention. The balance of gases, the distribution of minerals, even the reflectivity of the surface could carry traces of deliberate influence. Those signals might be subtle, too subtle for us to notice yet, but they could still be there. The idea that an entire planet once bore the mark of consciousness is staggering. It suggests that the universe is not silent, only archived in ways we don't yet understand. What kind of philosophy would emerge on a world where day and night lasted months? Where the sky was never clear and stars were never seen? Perhaps they understood existence not in terms of light and darkness, but in gradients, in transitions. They would have seen that change, not contrast, defines the world. On such a planet, beginnings and endings blur. Life fades into death, warmth into fire, time into stillness. Maybe that understanding shaped their culture. A science that blended seamlessly with spirituality, not as belief, but as recognition of continuity. In their long days, they would have watched the clouds drift endlessly. The horizon would never be sharp. Distance would always dissolve into haze. That alone would change how they imagined boundaries. They might have lacked the very idea of a horizon. To them, the world would feel infinite, unbroken, continuous. If they built societies, they might not have built nations. They might have lived in vast cooperative systems, flowing like the air itself, connected not by walls or roads, but by networks of shared exchange. Even their concept of individuality could have been different. In an environment where visibility is low and sound travels slowly, cooperation would be essential. Survival would depend on communication and synchronization. They might have evolved collective awareness, minds attuned to one another's presence in ways beyond words. The first dawn of civilization on Venus could have been the dawn of collective intelligence. A web of minds acting together, perceiving together, thinking together. When we look at Earth and imagine what might come after us, we think in terms of artifacts, ruins, signals, machines. But perhaps the greatest traces a civilization can leave behind are not physical. They are changes in atmosphere, in chemistry, in the fabric of the planet itself. The carbon dioxide that fills Venus's air could partly be natural, or it could partly be the byproduct of a world that once burned in ways we don't recognize, not with fire, but with transformation. Even so, the story of their existence doesn't have to end in despair. If they reached understanding deep enough, they might have found ways to transcend the loss of their surface world. Maybe they learned to migrate upward into the clouds where temperatures are mild and pressure tolerable. Floating colonies of microorganisms, remnants of a once complex biosphere, could have adapted to that layer, evolving over millions of years into something entirely new. Civilization of air drifting in perpetual motion, carried by wind, still circling their planet in endless patience. We might be looking at them right now and not even realize it. The unexplained chemical signatures we've detected in the atmosphere could be their legacy. Not cities, not ruins, but metabolism, continuing quietly above the clouds. Life reduced to its essence, stripped of technology and form, surviving as pure process. It's a humbling image. Intelligence dissolving back into nature. Consciousness becoming part of the planet's breath. It's possible that some of them tried to leave. The idea of escape would have occurred eventually, the same way it occurs to us. As their world grew hotter and less forgiving, they might have looked toward the faint blue point in their sky, the neighbor world still cool and wet, and wondered if they could reach it. The physics would have been cruel. The thick air that once protected them would also make flight to space difficult. But perhaps they found ways, launching small vessels, chemical balloons, technologies we can't imagine. Maybe only a few succeeded, carrying fragments of knowledge of biology, of history. If even one of those vessels reached Earth when it was young, their story might not have ended after all. It might have continued here, rewritten in new forms and new minds in us. Whether or not they existed, thinking about them deepens our own sense of continuity. It reminds us that intelligence is not inevitable, but possible wherever the right balance holds. It's fragile, conditional, temporary, yet capable of reshaping entire worlds. The architects of the first dawn, if they ever lived, did not fail. They were part of their planet's natural rhythm. They emerged from it, transformed it, and returned to it. In a universe that values persistence over permanence, that may be the only kind of success that matters. Even now, as we send orbiters and probes to study Venus, their world remains beyond reach. The clouds still hide everything. The heat still defies every landing. But maybe that's fitting. Maybe their story was never meant to be recovered fully, only felt through the data, through the imagination, through the quiet sense that we are not the first to wonder what it means to be alive under a changing sky. The first dawn of Venus has long since faded, but its light lingers in reflection, in memory, in the endless brightness we still see before sunrise. That light is their monument, their message, their echo across time. And as we continue through the story of this lost world, the horizon begins to shift once more. Not toward peace or silence, but toward the long unraveling that would follow when the heavens themselves began to turn against them, and the world that once nurtured life grew too hot to hold it any longer. Change on a planetary scale, rarely announces itself all at once. It begins as a whisper too subtle to notice, folded into the ordinary rhythm of things. A slightly warmer tide, a gentler rain that doesn't quite fall where it used to, clouds that drift differently, slower, heavier. For those who lived on Venus, if anyone did, the unraveling of their world would have begun quietly, almost kindly, as if the planet itself was giving them time to adjust. But time on Venus did not move as it does here. A single sunrise could stretch across generations, and the warning signs would have unfolded so slowly that no one could have known what they meant until it was too late. The warmth that had once nourished life became just a little stronger. The light filtered through endless clouds grew thicker, golden, and still. Perhaps there was comfort in it at first, the illusion that the planet was thriving, glowing from within. The seas steamed slightly more each year. The rain that fell carried faint traces of acidity born from subtle changes in the balance of gases in the air. It would have gone unnoticed by most forms of life. Only the smallest organisms, the most sensitive, would have felt the difference first. The ones that measured their world in chemistry, not sight. If there were scientists among them, they might have studied the change carefully as a curiosity at first. Atmospheric measurements recorded minor shifts in temperature and composition, clouds forming earlier in the day, the lower layers growing warmer than expected. The difference might have seemed trivial, an anomaly in the great cycle of the world, one that would surely correct itself. But the corrections never came. The heat rose imperceptibly day after day, century after century. Venus was beginning to lose its balance, though no one yet understood that it was a balance that could not be restored. Every planet depends on feedback. Energy comes in from the sun, bounces off clouds, warms the surface, rises, and escapes back into space. When that cycle works, the temperature holds steady. But on Venus, something began to interfere. Carbon dioxide released naturally from volcanoes began to accumulate faster than it could be reabsorbed by oceans and rock. The air thickened almost imperceptibly, the planet's breath slowing. A few degrees of warmth became a few more, and in those few degrees, the stability that had lasted for millions of years began to falter. The seas responded first. Evaporation increased. Clouds grew denser, and what had once been gentle rain became something different. Short, heavy bursts that never reached the ground, vaporizing in midair. The sky darkened from gold to copper, the clouds thickening until sunlight became a faint, eternal glow. The ocean shrank, not dramatically but continuously. Each century a little smaller, each generation of life moving closer to the remaining water. Coastal regions that had once supported vast ecosystems turned barren. The air thick and shimmering with heat. Those who lived through it would not have thought of it as the end. To them, it might have been merely another phase, another shift in the rhythm of the planet's long, slow breath. They might have adapted. Homes built closer to cooler regions. Instruments recalibrated to measure the thicker air. Crops or organisms bred for the new conditions. Every change would have seemed temporary, manageable. The belief in the world's endurance would have been strong, unshakable. After all, Venus had always been their home. It had always recovered until it didn't. Volcanoes erupted more frequently, releasing clouds of gas that lingered in the heavy air. The atmosphere became increasingly opaque, trapping the planet's heat with growing efficiency. The feedback loop that drives every greenhouse effect had begun. More heat meant more evaporation. More clouds meant more trapped heat. It was self-sustaining now, a chain reaction too vast for any intelligence to stop. The heavens were beginning to turn hostile. If you imagine standing there beneath that sky, it wouldn't have looked apocalyptic at first. The horizon would still have been soft, veiled by haze. The light would still have been warm, diffused, deceptively gentle. but the air would have felt heavier, harder to move through. The warmth clinging to the skin, seeping into everything. Winds would have shifted, carrying a faint metallic scent from volcanic gas. The sound of thunder would have been constant, a low murmur that rolled endlessly across the horizon. Eventually, the water cycle, that delicate engine of climate, would have broken. Rain stopped reaching the surface altogether. Clouds became permanent, unbroken, their undersides glowing with reflected sunlight. Below them, the land dried into a vast expanse of rock and mineral dust. Whatever lakes or shallow seas remained began to boil away, feeding the atmosphere with yet more vapor, yet more heat. The temperature rose, not gradually now, but exponentially. The balance had tipped. Venus was becoming its own furnace. If there were any still living who could comprehend it, they would have seen the signs with horror and fascination alike. The data would have shown the rising heat, the vanishing moisture, the growing concentration of greenhouse gases. They might have built machines to cool their cities, or shelters that reached into the depths of the ground. Underground, the temperature would have been stable for longer. Perhaps they dug networks, vast labyrinths of life and knowledge, trying to wait out the warming. But time was against them. The planet was not merely changing its surface conditions. It was transforming its very chemistry. The oceans that once moderated the air were gone. The carbon dioxide they had absorbed for eons returned to the atmosphere, amplifying the heat. The surface pressure climbed to crushing levels, the equivalent of nearly a kilometer underwater. Volcanic activity surged, releasing even more gas, feeding the spiral. Lightning crackled through the upper clouds, igniting no fires. There was nothing left to burn but charging the air with energy. The storms became endless. The sky flashed and rolled with thunder that never faded. On Earth, we speak of climate change in terms of degrees and thresholds. On Venus, there would have been no thresholds left. Once the point of no return was crossed, the transformation accelerated until the planet became a different kind of world altogether. The air itself thickened into a fluid. The surface temperature climbed past the melting point of the lead, and the last traces of water disappeared. The heavens had turned fully hostile, and the cycle of life that once flourished there had ended. But the story of the great unraveling isn't only about destruction. It's about inevitability. Venus was always destined to move this way. It existed just a little closer to the sun, just enough for the balance to shift toward heat rather than cool. Every planet carries its own equilibrium, and Venus's was simply less forgiving. What began as a soft increase in temperature became a cascade that no living system could survive. The laws of physics don't negotiate. They continue, and the planet in its own way was simply following those laws. Still, if any intelligence had persisted, even for a while, it might have tried to preserve itself in some form. The atmosphere itself could have been used as storage, chemical markers left behind as messages, patterns encoded in trace elements. Or perhaps they turned their efforts upward, building vast platforms in the high clouds, where temperatures and pressures remained mild. There, in the temperate layer of the atmosphere, life could continue long after the surface was lost. It might have evolved again, reshaped itself to drift with the wind, feeding on the chemical richness of the air. Aerial life not as a dream, but as adaptation. In that way, the unraveling might not have been the end, but a transformation. Life changing from surface dwelling to sky dwelling, from grounded to free floating. The planet too would have adapted, though not in ways we would call merciful. As the surface turned molten, the atmosphere became a sea of gas and acid. The two merged into a single system, planet and air indistinguishable. The boundary between sky and ground blurred until it ceased to exist. From orbit, the planet would have looked strangely serene, its surface hidden beneath bright clouds. The violence beneath those clouds would have been invisible, its destruction disguised as beauty. It's difficult not to see parallels with our own world. The same physical processes that destroyed Venus exist here, just held in check by oceans, by vegetation, by balance. The difference is degree, not kind. Studying Venus's unraveling is not just about learning the fate of another planet. It's about seeing how delicate the equilibrium of life really is. The warmth we depend on, the thin air we breathe, the cycles of water and carbon we take for granted. All of these are narrow windows in a vast spectrum of possibility. Venus shows us what happens when the window closes. As the atmosphere thickened, sunlight ceased to reach the surface directly. The world dimmed into a permanent orange glow. Nights vanished. Stars were forgotten. The air became the only sky anyone could ever see. In that endless twilight, the sense of time itself would have dissolved. The long rotation that once defined their rhythm now only deepened the monotony. The surface, trapped under its own heat, would have become motionless, unchanging still. If any life remained, it would have been blind to the surface, living entirely within the clouds, unaware that the world below had turned to fire. It's possible that the unraveling continued for millions of years after life had already gone. The physical processes didn't stop with extinction. Carbon continued to cycle between rock and air. The atmosphere continued to thicken. The heat continued to rise. The planet's crust softened, allowing volcanoes to resurface the entire globe. Then at last, equilibrium returned. Not the gentle balance of life, but the harsh balance of death. Temperatures stabilized. Chemistry froze into stasis, and the planet entered a kind of calm. The great unraveling had ended, leaving behind silence and heat. But even silence holds echoes. The atmosphere we see today, dense and opaque, is the final record of that transformation. Every molecule of carbon dioxide there was once part of rock, water, or life. Every drop of acid in the clouds is an artifact of a lost ocean. When we study Venus now, we are reading the last page of a story written in chemistry. It's a story that reminds us that creation and destruction are not opposites, but stages of the same process. The heavens turned hostile, not because of malice, but because of momentum. The planet simply continued along the path nature had set for it. Yet in doing so, it became something strangely eternal, unchanging, enduring, a monument to its own transformation. If there were witnesses at the end, their final vision would not have been fire and chaos, but light. The whole sky glowing softly, endlessly as their world disappeared beneath it. That glow remains. It's what we see now, every morning and evening when Venus shines in our sky. Bright, constant, and indifferent, the unraveling turned their heavens hostile. But it also made them beautiful. The light that marks our dawns and dusks as their legacy. The reflection of a world that once breathed and then fell silent, still casting its glow across the void. And as that glow lingers, the story moves onward, carried by sunlight and time, toward what came after the unraveling, toward the echoes that drift across the solar wind. Fragments of what once was, still whispering quietly in the space between worlds. When a planet dies, its silence doesn't spread instantly. It lingers, slowly unraveling into space, atom by atom, molecule by molecule, carried by the faint but endless breath of the solar wind. Venus may have fallen quiet billions of years ago, but its traces continue to drift outward, mingling with dust and light, crossing the invisible highways between worlds. The story of what happened there isn't entirely gone. It's written in particles, in fields, in faint patterns that still whisper through the solar system. The solar wind itself is a strange thing to imagine. It isn't really wind, not the way we know it. It's a constant stream of charged particles flowing outward from the sun. Protons, electrons, fragments of atoms born from the star's heat. They travel across space at hundreds of km/s, washing over every planet. Shaping magnetic fields, sculpting tales of ionized gas behind comets. It's the sun's invisible touch, and everything in the solar system feels it. Venus has no strong magnetic field of its own to protect it. Its atmosphere is constantly exposed to that stream of particles, eroding, reshaping, leaking into space. Every second, bits of its air are stripped away, carried off into the void. If you could stand on a quiet observation platform, floating just beyond the planet's reach, you might see it as a faint shimmer, an unseen wind brushing against the edge of the atmosphere, scattering ions like glitter in the dark. The particles that leave Venus don't vanish. They join the flow that connects all the worlds, drifting along invisible currents. Somewhere in that stream are the remnants of what the planet once was. Oxygen that once belonged to water, carbon from volcanic exhalations, sulfur from the clouds, and perhaps in the smallest quantities, atoms that were once part of living things. Those atoms now wander endlessly, crossing orbits, sometimes caught for a moment in the gravity of another world before continuing on their way. The solar wind is a kind of messenger. It carries the fingerprints of each planet it touches. When scientists study the magnetic field lines and plasma around Venus, they see the echoes of its lost atmosphere. The patterns of ions tell a story of erosion, how the upper layers of air were stripped away by solar energy over billions of years. Hydrogen, the lightest element, escaped first, leaving behind a world without water. Heavier elements followed more slowly, creating long trails of particles that extend far into space. These are the ghostly remnants of Venus's past oceans, still moving outward, still telling their story in silence. Some of those atoms drifting through space might eventually reach Earth. They would fall through our own atmosphere unnoticed, mixing with our air, becoming part of the same molecules that fill our lungs. It's an odd thought that with every breath we might inhale tiny pieces of that vanished world. Not enough to measure, but enough to connect. Enough to say that the memory of Venus isn't just distant. It's literally part of us. The universe doesn't separate stories cleanly. It recycles them. What's lost in one place becomes part of another. The same might be true on a larger scale. When asteroids or comets strike a planet, they can throw fragments of its crust into space. On Earth, we found meteorites from Mars carrying the chemical fingerprints of that planet's surface. They're solid pieces of another world, billions of years old, preserved in stone. If Mars rocks can reach us, so could Venus's. Though its thick atmosphere makes the journey more difficult, the possibility remains. During massive impacts, especially in the planet's earlier history, debris could have been launched into orbit, some of it escaping completely. Those fragments would have drifted through space for eons, some drawn toward the sun, others flung outward. A few could have crossed Earth's orbit and fallen here, unnoticed, long before life began. If that happened, those fragments might have carried more than minerals. Inside small pockets of rock, shielded from radiation, there could have been remnants of organic molecules, maybe even dormant microbes. It's a fragile possibility, but not impossible. The journey through space is harsh. Temperatures swing wildly. Cosmic rays bombard everything. Yet life has shown remarkable resilience. Bacteria on Earth can survive vacuum, radiation, and freezing. They can remain inactive for centuries and still awaken when conditions improve. If any such organism had existed on Venus before its great unraveling, and if even a few of them were protected within impact debris, they could have made the crossing. They could have landed in the early oceans of Earth, finding a new home on a cooler, quieter world. That idea changes how we think about beginnings. It means life might not be something that starts over and over from nothing, but something that migrates, adapting and continuing wherever it can. The story of Earth's biosphere could be a continuation of Venus's. The first spark may have been lit beneath that soft golden sky, and the flame carried here across the emptiness. If so, the first living things on our planet were not truly native. They were refugees from a world that could no longer hold them. Even now, Venus continues to send small traces into space. Every interaction between its atmosphere and the solar wind releases new material. Instruments aboard orbiting spacecraft measure streams of ions escaping from the planet's shadowed side, trailing away like invisible smoke. These are the ongoing echoes of the unraveling, the last exhalations of a world that still breathes in its own strange way. It's not dead, just different. The planet continues to interact, to communicate, to participate in the vast conversation of energy and matter that fills the solar system. If we were to listen closely, not with ears, but with instruments, we would hear those whispers. The magnetic field that wraps around Venus when the solar wind hits it produces low-frequency waves, faint hums that can be translated into sound. In recordings made by spacecraft, those sounds resemble distant thunder or a deep, slow heartbeat. It's the voice of the planet's interaction with the sun, not language. But resonance. To some, it sounds eerie. To others, strangely comforting. It's a reminder that even silence has texture. Even emptiness has rhythm. Some of the particles leaving Venus will drift toward the outer planets, joining the solar wind's long journey past Mars, Jupiter, and Saturn out to the edges of the heliosphere. There they'll mix with material from other worlds, from comets, from the interstellar medium beyond. Eventually, some will escape entirely, carried out into the galaxy. The atoms that once formed part of Venus's oceans might one day become part of distant stars, or part of new planets forming around them. The universe wastes nothing. Everything, even loss, becomes fuel for something new. And perhaps somewhere far from here in another system entirely, life will emerge on a world warmed by another sun. Its oceans will glimmer. Its skies will glow. And deep within its chemistry, there will be atoms that once belonged to Venus. The story of that planet won't end here. It will continue, just written in a different language of molecules and light. Closer to home, the echoes of Venus are still being studied. Scientists continue to analyze the data from orbiters and landers, searching for chemical signatures that don't quite fit the models. In recent years, unusual compounds have been detected in its upper atmosphere. Phosphine, sulfur dioxide in unexpected concentrations, complex hydrocarbons. None of these are proof of life, but they are puzzles. And every puzzle invites curiosity. It's as though the planet still holds back pieces of its history, letting us find them one at a time. Never enough to see the full picture, but enough to keep us listening. Every mission sent to Venus becomes part of this conversation. The spacecraft that orbit it are like emissaries recording the faint electrical interactions between solar wind and atmosphere, mapping the flow of particles that escape into space. They show us that even in apparent stillness, the planet is active. The solar wind doesn't just strip the atmosphere. It shapes it, stirs it, breathes through it. The boundary between Venus and space, called the ionosphere, is alive with motion. Charged particles swirl, twist, and collide, forming auroras invisible to human eyes. The night side of the planet glows faintly in infrared, not from sunlight, but from the heat that refuses to fade. When you look at Venus in the evening sky, you're seeing that heat made visible. Sunlight reflected by clouds. Yes, but also the faint memory of a planet that still radiates from within. Its surface remains hotter than any other in the solar system. Its energy locked in place, unable to escape. That heat pushes outward, rising through the atmosphere, meeting the solar wind at the edge of space. There, the two forces interact, creating a boundary where energy and matter dance endlessly. The echoes of that dance travel outward, carried by light, by plasma, by time itself. It's humbling to realize how connected everything is. We think of planets as isolated, each in its own orbit, separate and self-contained. But the solar wind ties them together. It's the bloodstream of the solar system, carrying the chemistry of one world to another. The oxygen from Earth, the dust from Mars, the gas from Venus, all of it mingles out there, indistinguishable, forming a shared atmosphere that belongs to the Sun and all its children. The differences we see are only temporary. Over cosmic time, the materials mix, exchange, and recycle endlessly. There's no true isolation in space, only distance. That means the legacy of Venus is not confined to itself. It's spread across the entire solar system. Tiny pieces of its air, its rocks, its past are everywhere. In meteorites, in interplanetary dust, in the faint haze of plasma that surrounds the Sun, even the magnetic storms that ripple through space carry its influence, shaped by how the solar wind flows around it. To study Venus is to study an entire system, not a single planet. Sometimes scientists speculate that certain isotopes in our atmosphere might have originated elsewhere, carried by these same cosmic currents. The idea is difficult to prove, but even the thought changes how we see ourselves. We are not separate from the story of Venus. We are part of it. The boundary between their world and ours is not as sharp as it seems. Matter, like memory, drifts freely. What was once theirs is now ours, and what is ours will one day belong to others. In that sense, the solar wind is not just a physical phenomenon. It's continuity. It ensures that no world, however silent, is ever completely forgotten. The atoms leaving Venus now will outlast our species, our planet, and maybe even our sun. They'll keep moving, carrying the faint chemical signatures of oceans, clouds, and perhaps life. They'll pass through interstellar space long after we're gone, whispering the story of a bright planet that once shone beside Earth. And while they drift, we'll continue to look upward, catching glimpses of their origin in the morning sky. Venus will keep shining, steady and beautiful, its brilliance undiminished by its history. Every glimmer of that light is a reflection of loss and persistence combined. The glow of a world that refused to vanish quietly. Its story travels not just through light, but through dust, through ions, through every particle that slips away into the solar wind. Even now, those particles are moving past our world, unseen, blending with our air, settling into oceans, joining the endless exchange that keeps everything connected. Somewhere above you at this very moment, high in Earth's upper atmosphere, a molecule from Venus might be gliding past, carried by the same currents that shape auroras and storms. You wouldn't notice it. No one would. But it's there, a silent messenger from a world that once may have known itself, now carried forward by physics and chance. The echoes are all around us in the air, in the dust, in the faint hum of radio waves that ripple through space. We listen to them through machines, through equations, through imagination. They remind us that the universe keeps nothing entirely to itself. Every world speaks even after it's gone. Some speak through light, others through gravity, others still through the slow drift of atoms that never stop moving. Venus speaks through all of them softly, steadily, endlessly. And in that whisper carried by the solar wind, the story continues, flowing toward the next reflection. The planet that survived where Venus did not. The twin that still holds oceans, air, and fragile life. The mirror of Earth waiting quietly in that shared light, where the story bends back toward us again. When we look at Venus, we are looking into a mirror. Not the kind that returns our faces, but the kind that shows a possible version of ourselves, a reflection from another's timeline. It is difficult to think of a planet as a mirror, but in a way, that's what it is. The same size, the same gravity, the same rocky structure, the same beginnings. Venus and Earth were made from the same dust, the same heat, the same cosmic ingredients. They were born beside each other, warmed by the same star and shaped by the same physical laws. They are siblings that grew apart, separated not by distance but by destiny. When we study Venus, we're not just learning about another planet. We're looking at what might have been, what could still be, if our balance shifted even slightly. From space, the resemblance is undeniable. Both worlds are nearly the same diameter. Both orbit in the narrow band where liquid water can exist, where sunlight is gentle enough to nurture but strong enough to sustain. Both have mountains and valleys, clouds and weather, volcanoes and tectonic histories. For billions of years, they moved in tandem around the sun, close enough to share its light, close enough that each could see the other as a bright star in its sky. But one became a cradle for life, and the other became a furnace. The question that has haunted scientists for decades is why. The simplest answer lies in the small differences. Venus is a little closer to the sun, about 70% of Earth's distance. That extra sunlight was enough to shift the equilibrium. When the first atmosphere is formed, Venus receives slightly more energy than it could release. Over time, that imbalance grew. Water evaporated faster. Carbon dioxide accumulated. Heat built up and stayed. But the line between the two worlds was thin. Perhaps only a few degrees of temperature, a few million km of distance. The same processes that sustain life here could have destroyed it there. That narrowness is what makes the comparison so powerful. Looking at Venus is like seeing a photograph of Earth's future, taken billions of years ahead. The same physics that turned its air into acid and its seas into vapor could one day affect us. The sun is slowly brightening as it ages. In another billion years, it will shine more fiercely, and Earth's own balance could tip toward warmth just as Venus's did. The oceans could shrink, the air could thicken, and the blue could fade into gold. When we look at Venus, we see that outcome already completed, preserved for us in the present. It's a warning written in light, a message sent through time. And yet, there's more than fear in that reflection. There's recognition. Venus's story is not only one of loss, but of persistence. Even after its transformation, it continues to shine brighter than any other planet in our sky. Its brilliance is not a sign of life, but it feels like one. It reminds us that even in ruin, there can be beauty. Even in failure, there can be endurance. The light we see every evening and morning is the same light that once touched its oceans. The same sunlight that now warms our own. It's the shared inheritance of two worlds that began together. Sometimes it helps to imagine what Earth would look like from Venus. From its skis through the thick golden haze, Earth would appear as a pale blue point, softly pulsing in the distance. To them we would look like hope, cool, gentle, balanced. To us they look like warning, bright, restless, intense. The two planets have always been reflections of one another, each showing the other what it lacks, what it might become. If there was ever consciousness on Venus, perhaps it looked toward Earth and saw salvation, the same way we now look toward Venus and see caution. The connection between the two is not only poetic, it's physical. Everyday particles move between them. Dust from impacts, ions carried by the solar wind, photons reflected and shared. Our atmospheres are not sealed. In the upper reaches of space, their boundaries blur. The atoms of one world mix with those of another. Even without life, there is communication. A steady exchange of matter, energy, and memory. The mirror is not just visual. It's chemical. When scientists model the climates of other planets, they often use Venus and Earth together as twin case studies. One stable, one unstable, one that found balance, one that lost it. What they learn from Venus helps explain the mechanisms that keep our world livable. The way water cycles through ocean and sky. The way carbon dioxide moves between air and rock. The way clouds form and reflect sunlight. These are the systems that maintain equilibrium. The silent harmonies that allow us to exist. On Venus, those same systems went out of tune. Studying the difference helps us hear our own song more clearly. It's easy to think of the planets as fixed, but they are all in motion. not just around the sun, but within themselves. Atmospheres shift. Magnetic fields fade. Surfaces renew. Earth is stable now. But that stability is the product of constant motion. Our atmosphere, our oceans, even our biosphere are always adjusting to subtle changes in sunlight and chemistry. Venus once did the same until it reached a point where adjustment was no longer possible. It's like watching two pendulums swing side by side. One slows and steadies, the other accelerates until it breaks from rhythm. Both respond to the same forces. The difference lies in timing. Venus's surface is young geologically speaking. Most of it was reshaped by volcanic activity within the last billion years. On Earth, that same process creates mountains, islands, and fertile soil. On Venus, it remade the entire planet at once. The lava that poured from its volcanoes released immense amounts of carbon dioxide, thickening the atmosphere, feeding the runaway greenhouse. Earth has volcanoes too, but it also has oceans and life to absorb their output. The balance between fire and water keeps the system stable. Venus had fire without water. That one missing ingredient changed everything. There's something haunting about that thought. That habitability depends on such a fragile equation. Change one variable, and paradise becomes prison. It's a reminder that our comfort here is temporary, conditional. The mirror doesn't lie. What we see on Venus is the continuation of the same physics that governs Earth. Our difference is only a matter of balance, and balance is never permanent. But maybe the mirror shows more than warning. Maybe it shows possibility. If Venus and Earth share origins, then studying Venus could help us understand not just our own limits, but our potential. The processes that destroyed its oceans could in theory be reversed. At least in imagination, someday, perhaps far in the future, humanity might learn to cool it, to seed its atmosphere with new compounds, to create stability again. Not to inhabit it, but to restore it. Terraforming is still a dream, but it's one inspired by reflection. The desire to see in that mirror not just ourselves, but redemption. There's a quiet beauty in that idea. The notion that one day the children of Earth might return to their planet's twin, not as conquerors, but as caretakers, reawakening what was lost. It's unlikely, maybe impossible, but it changes how we see the relationship. The mirror doesn't only reflect our failures, it reflects our responsibility. To study Venus is to remember that worlds can die. To care for Earth is to ensure that ours doesn't. And yet, when you set aside the science, there's something emotional about the connection that's harder to define. The light of Venus has guided travelers for thousands of years. It has been the morning star, the evening star, the first and last to appear in the sky. Every culture has given it a name. Every era has watched it. It has been a symbol of beauty, of love, of rebirth. We've built myths around it, not because it's distant, but because it feels familiar. It's not like the outer planets, cold and abstract. It's close, visible, steady. It feels like home's reflection. Another world always watching. When you think about how light travels, the feeling deepens. The photons that strike your eyes when you see Venus left the sun 8 minutes ago, bounced off its clouds, and reached you after another 6. That light has touched both worlds. It has passed through their atmospheres, reflected from their surfaces, and returned to space. When you see it, you're seeing sunlight that has already traveled between siblings, carrying their shared history in its glow. It's not metaphorical. It's real physics. The connection is constant, renewed every moment. If there were once eyes on Venus, they would have seen Earth as we see them now. A bright, shining world near the horizon, fading and reappearing with the slow rhythm of orbits. Perhaps they gave us names the way we gave them theirs. Perhaps they built their own stories about the blue star that rose and fell in their skis. Maybe they wondered what it was like there, what it meant to exist in such distant light. The mirror goes both ways. If consciousness once lived there, then for a brief period in cosmic time, two worlds looked at each other and wondered. Now only one remains to remember. But even that memory is incomplete, fragmented across data and dreams. The light that connects the two still shines, though unchanged by the passing of time. It continues to rise and set, to shimmer in dawn and dusk. The planets still move in their old rhythm, bound by the same gravity that has held them since the beginning. The mirror has cracked but not shattered. The reflection is distorted but still there. When scientists simulate the future of Earth, they often compare it to Venus's present. If our oceans evaporate, if carbon builds in our air unchecked, if feedback loops begin to accelerate, our atmosphere could thicken, our clouds could change, and our world could grow hotter. It's not a prophecy, only a possibility, but the resemblance is unavoidable. The mirror shows what happens when equilibrium is lost. It doesn't threaten us. It teaches us. It reminds us that no planet is permanent, that every climate is temporary, that survival requires care. Sometimes when you see Venus just above the horizon at dusk, it looks impossibly bright, as if it shouldn't be real. It shines so strongly that it almost seems to hover closer than the moon. It feels near, even though it's millions of kilometers away. That's the illusion of mirrors. They bring distant things close, turning space into intimacy. The same happens in thought. When we think of Venus, we bring it near. We see our own future, our own reflection, our own responsibility. The distance disappears. If you imagine both planets at their beginnings, side by side in the young solar system, they would have been nearly indistinguishable. Two glowing spheres cooling from fire, both with oceans forming, both covered in clouds. The difference that later grew into tragedy would have been invisible then. Perhaps there's a comfort in that, in knowing that for a while they were the same, for a brief cosmic moment. There was no mirror, only two versions of life's possibility shining together under the same sun. That unity, however brief, still echoes. The particles of one world continue to mix with the other. The light that leaves one still reaches the other. The connection remains even after everything else has changed. Venus reflects more than sunlight. It reflects continuity. It reminds us that all worlds share the same beginning and the same end. That difference is only delay. That existence itself is a fragile balance between creation and decay. And through that reflection, the story turns again back toward motion. Because if life began there and drifted here, and if we are its continuation, then we carry their memory not just in thought, but in being. The mirror does not simply show us, it extends us. Somewhere within our own oceans, within our own cells, may lie the faint echo of that first world's chemistry, the inheritance of its time, its air, its seas. We are not just observing Venus. We may be remembering it. The thought softens everything. It makes the mirror feel less like a warning and more like a reunion. Two worlds still connected, still speaking through light and wind and time. And as we look into that brightness tonight, we might see not just what they became, but what we are. The continuation of a story that didn't end when their world turned hostile, but kept going, reshaped, reimagined, reborn under gentler skies. And through that continuity, the light lingers, pulling us toward the next thought, the next question, the next motion of that shared history, carried from one world to another like a memory in flight, whispering that nothing truly ends, that everything moves forward always into the long migration of souls. When people speak of migration, they usually mean distance, a journey across land or sea, a passage from one home to another. But there is another kind, quieter and slower, that happens not across geography, but across time. It's the movement of memory, of essence, of what remains when formers faded. If Venus ever held life, then its story didn't stop when its oceans vanished. The material that made that life, The atoms, the patterns, the traces, all continued onward. The long migration of souls began not as an act of will, but as a natural process. The planet exhaled, and its breath joined the currents of the solar wind, the flow of dust, the endless drift that moves between worlds. What began as life on one world may have become potential on another. It's strange to think of matter as having memory, but in a way it does. Every atom carries its own history. The carbon in your body once drifted in interstellar clouds, condensed into a star, and later formed part of a planet. It has already lived through fire and vacuum through birth and destruction. The calcium in your bones might have come from a supernova that exploded before our sun was born. When you trace the origin of anything far enough, you find that nothing begins here. Everything is inherited. The long migration didn't start with us or with Venus, but with the first atoms that ever formed. Still, there's something poetic about imagining that migration continuing in a way more personal, more local. If Venus once had living things, they would have left their traces everywhere. Not just in the particles drifting through space, but in the possibilities they created. Maybe some of them reached Earth as fragments embedded in meteorites or carried in clouds of dust. Maybe their chemistry inspired our own beginnings. And maybe in a way that no measurement can ever confirm, part of their essence found its way into us. It's not a scientific claim, but a reflection that life once begun tends not to disappear entirely. It changes form. It migrates. The word soul doesn't have to mean spirit. Here it can mean continuity. The thread of existence that moves from one state to another, connecting what came before to what comes after. If Venus's oceans once shimmered with life, then the molecules that formed those beings are still here somewhere, scattered through the solar system, waiting to join new systems, new worlds, new bodies. The migration is not one of choice, but of nature. The same laws that destroy also disperse, and what is dispersed eventually gathers again. When we think about how matter travels, it helps to imagine the invisible bridges that link everything. The solar wind is one. Gravity is another. Impacts, radiation, electromagnetic fields. They all move material between worlds. Nothing stays entirely where it began. The migration of souls is built into physics itself. Over billions of years. Even the heaviest elements drift, and the boundaries between planets blur. If you could see it, space wouldn't look empty. It would look like a slow, luminous tide, carrying fragments of everything everywhere. Venus, Earth, Mars, all exchanging material in the great patient rhythm of time. This is how memory works on a cosmic scale. A planet dies, but its story doesn't. Its atoms are absorbed into new forms. Its heat becomes radiation. Its minerals return to dust. Even ideas, once they arise, follow the same law. Thought spreads, fragments, migrates. Maybe that's what consciousness really is. Not something that belongs to one species or one world, but something that moves through matter, finding new shapes whenever conditions allow. If we extend that idea back to Venus, the image becomes clearer. Imagine that as its surface grew hotter. As its seas evaporated, the last surviving organisms clung to the upper layers of the atmosphere where the air was still cool. They drifted there, carried by wind, multiplying, surviving until the winds lifted them higher and higher. Some escaped into space. Not alive in the way we define it, but still organized, still holding patterns that life could recognize. Those patterns could have drifted to Earth, settling into its young oceans, merging with whatever chemistry was already forming there. Life on Earth could then be seen as the continuation of that migration. The soul of one planet finding a new home in another. It's not an impossible thought. The space between Venus and Earth is small in cosmic terms. Rocks have crossed it before, pushed by impacts falling from one world to the next. Within those rocks, microbes could survive for thousands of years, protected by layers of stone from radiation. When they landed on Earth, they could have awakened, found warmth, and continued. It's a version of panspermia, but with a personal twist. Instead of life coming from distant stars, it comes from our neighbor, our twin, that makes us not just observers of Venus, but descendants. If that's true, then everything we are carries a memory of that world, not consciously, but chemically. The same carbon that once fed life under its thick skis might now build our cells. The same nitrogen that once filled its air might circulate in our veins. The migration of souls is not mystical, it's physical. It's the movement of matter toward complexity, the continuation of pattern through time. Each life form on Earth would then be part of a vast ongoing process. The reassembly of what was lost piece by piece into new arrangements. Perhaps that's why Venus continues to fascinate us. It's not just a planet we study. It's a planet we recognize. When we see it in the morning sky, something deep in us stirs something ancient and unspoken. It might be memory. It might be resonance. It might simply be the recognition of kinship. Every time we look at it, we are seeing not just a distant world, but a reflection of our own beginnings. The place where the long migration may have started. Even if life never existed there, the possibility itself carries meaning. It shows that conditions for life are not unique. That the universe is capable of creating similar worlds, similar stories. Venus is proof that habitability is not a miracle, but a potential repeated throughout space. Its loss makes our survival here more significant. It reminds us that the journey of life is not guaranteed but earned, maintained through balance and care. The migration continues only as long as we allow it. For a moment, imagine the migration not as atoms or microbes, but as awareness. A consciousness that once looked out from Venus, saw its world bright and calm, then faded into heat and dust, only to reappear somewhere else reshaped by time. If consciousness is an emergent property of matter, then it too is transferable in principle. The awareness that exists here could be the continuation of an awareness that existed there, not as reincarnation, but as reconfiguration, the same universe. Thinking again through different forms. Every breath you take includes atoms older than Earth itself. Every thought you have depends on particles forged in ancient stars. The idea that some of those particles once belonged to another living system is not poetic. It's statistical. It's almost certain. The migration of souls is happening continuously in and around us in every exchange of air and energy. The line between one life and another, one planet and another, is not as firm as it seems. Even the act of looking at Venus continues that migration. The photons that reach your eyes are physical carriers of information. Pieces of energy that left the sun, touched Venus's clouds and returned here. When they strike the retina, they trigger signals, electrical impulses, chemical reactions in your brain. In that moment, part of Venus becomes part of you. The connection isn't symbolic. It's literal. The long migration moves through light as well as matter. The universe shares itself constantly. It's possible that in the far future, this process will reverse. When the sun grows hotter, Earth will face its own unraveling. Our oceans will shrink, our air will thicken, and life as we know it will fade. But perhaps before that happens, pieces of our planet will escape, carried by impacts, dust, or deliberate design. Maybe fragments of us will drift toward Mars or the moons of Jupiter, or even back toward Venus, which by then will have cooled slightly under a dimmer sun. The migration will continue. Each generation of worlds gives something to the next. Nothing ends. It only moves. This perspective changes the meaning of existence. It suggests that life is not a product of one world, but a function of the universe itself. Matter wants to organize. Energy wants to move, and in that movement awareness arises again and again. Planets are the temporary stages for that process. They are vessels, not destinations. When one fails, another begins. The migration of souls is simply the universe remembering itself in new forms. Venus, then, is not a lost world, but a stage in that continuity. Its light still travels. Its material still circulates. Its influence still shapes us. The migration it began hasn't stopped. It has only shifted to new hosts, new minds, new ways of being. Every discovery we make about it, every spectral reading, every radar map, every trace of chemistry is part of that same journey. Understanding is another form of migration, the movement of knowledge across time. And perhaps one day, when we finally send humans to orbit Venus to float in the upper atmosphere where the pressure and temperature are almost Earth-like, we will complete a circle we didn't know we were part of. We will return not as strangers, but as descendants, carried there by the same physics that once carried their atoms here. We will breathe air filtered through the same sunlight that once warmed their seas. And in doing so, we will bring their story home. It's comforting to imagine that, to think of history not as something linear, but as something circular, cyclical, shared. The migration of souls isn't a departure or an arrival. It's a constant exchange, a never-ending movement through the layers of existence. Even the smallest action, a spark of thought, a beam of light, a falling particle continues that flow. The universe keeps nothing separate for long. And so the story continues, the migration moving softly onward, carrying not only atoms and molecules, but ideas, feelings, and awareness from one planet to the next. From one age to another, it never truly ends. It only changes its form, as it always has, as it always will. And within that quiet motion, we find ourselves drifting too. The children of a vanished world, still moving through its echo, still reflecting its light, still listening for the silence that once was its voice, waiting for what comes after the migration in the long stillness of the sister planet's eternal storm. Silence isn't the absence of sound. It's what remains when everything else has finished speaking. On Venus, silence came slowly, as though the planet resisted the end of its own voice. For billions of years, its atmosphere roared with storms, its volcanoes murmured beneath the clouds, and its surface crackled with heat. Then, gradually, the movement faded. The last oceans vanished. The last winds near the ground stilled, and what remained was the heavy hush of air too thick to carry sound the way it once did. The sister planet fell silent, not because it stopped existing, but because it reached a kind of equilibrium that no longer needed change. It had said everything it was ever going to say. If you could stand on the surface of Venus today, though no one ever truly could, you would find that silence everywhere. The air would press around you like water, dense and unmoving, muting every vibration. Your footsteps would make no echo. Even your breath, if it could survive in that heat, would vanish before it reached your ears. The temperature would be unbearable. The sky a dull orange that never darkens. And the ground beneath your feet would feel ancient, hardened by ages of fire. The silence there isn't peaceful in the way we think of quiet forests or calm seas. It's deeper than peace, older than rest. It's the stillness of completion. The atmosphere itself is still in motion. The upper layers racing around the planet in just a few days. But down below, near the surface, movement hardly exists. The air is so dense it behaves like a liquid, dragging everything it touches, smoothing edges, dampening every disturbance. Sound travels there, but slowly, warped and softened, stripped of sharpness. Even lightning, which flashes constantly high above, would make no thunder you could hear. The energy disperses into the thick air before it reaches the ground. The result is a world of sightless storms and voiceless flashes, all happening behind a curtain of silence. That silence has a strange kind of beauty. It's not emptiness. It's endurance. Every rock and every drop of acid cloud above it is a survivor. The surface we see now has been burned, crushed, and melted countless times. Yet it remains. The air above it has been stripped by solar winds, replenished by volcanoes, transformed by chemistry, yet it persists. The silence of the sister planet is not the silence of death. It's the silence of survival after everything else has already happened. From orbit, Venus looks calm. Its cloud tops are smooth. Its light steady. There are no visible storms like the ones that swirl across Jupiter. No great scars like Mars canyons. No glittering oceans to break the reflection. The uniform brightness hides everything. The chaos below, the heat, the pressure, the storms that never stop. It's a world where appearance deceives completely. The silence we perceive from Earth, that steady shining calm, is a reflection of what we want to believe. That quiet means safety. That stillness means peace. But on Venus, quiet and peace are opposites. The calm we see is the final state of a world that burned itself still. And yet, there's something comforting about that. The planet no longer changes violently. Its silence is a kind of stability, a steady hum at the edge of perception. When radio waves bounce off its surface, they return faint, distorted, as if coming from underwater. That distortion carries the sound of stillness, the echo of a place that has reached its end and remained there. Listening to it is like hearing the heartbeat of stone. Every mission that has visited Venus has met that silence firsthand. The first probes that descended through the atmosphere in the 1960s, and sevens recorded wind speeds, temperatures, pressures, and light levels. But when they reached the surface, their microphones found almost nothing. A faint hum from the lander itself, the whisper of static, then quiet. The signals faded one by one as the heat overwhelmed them. The Soviet Veneer probes lasted only minutes. They transmitted their final words, pictures of flat stones, data on pressure, then stopped. Each one joined the silence it had come to study. And yet the data they sent back wasn't empty. It was rich with meaning, full of the planet's quiet voice rendered through instruments. The brightness of the rocks, the scattering of light, the subtle gradients of heat, all of it spoke of what silence truly is on Venus. It's not absence. It's weight. The planet doesn't need to move or make noise to exist. It simply endures, pressing its presence into everything around it. There's a particular kind of reflection that happens when we think about silence on this scale. On Earth, we fill every space with movement, with sound, with change. Our planet hums with noise, wind, water, life, industry. It's easy to forget that silence is the natural state of things. The stars are silent. The moon is silent. Most of the universe exists in near-perfect stillness. Venus reminds us of that. Its silence is not isolation. It's the baseline from which everything else deviates. It's what remains when the story pauses between chapters. The more we study Venus, the more we realize that its silence is not empty of information. Its atmosphere hums with electromagnetic energy. Its surface emits heat that fluctuates with time of day and elevation. Its clouds swirl in patterns that follow mathematical rhythms, like invisible music played on scales of light and pressure. Every quiet moment on Venus is filled with motion too slow or too subtle for our senses to grasp. The planet may not speak in sound, but it speaks in patterns, in repetition, in the language of equilibrium. If we were able to live there, not on the surface, but in the clouds where conditions are gentler, we might hear a different kind of quiet. Up there, winds race at hundreds of km, carrying dust and droplets of acid. The air is thick but cool, the light soft and diffused. The silence there wouldn't be oppressive. It would be continuous, like the sound of your own breathing inside your body. Maybe that's the closest thing to calm the planet still, has the endless flow of its upper atmosphere looping around itself forever. When you think of Venus in this way, as a world defined by silence, it starts to feel less like a warning and more like a teacher. It shows us what happens when energy runs its full course. When motion becomes memory, the silence is not punishment. It's the natural conclusion of a process that began long before us. The planet burned, boiled, changed, and then stopped needing to. It found a kind of final balance, harsh but stable. That stability, that quiet, is something the universe seems to value. It's not an ending. It's rest. If life did exist there once, its traces are hidden in that rest. Somewhere beneath the thick crust, molecules might still sleep in rock, preserved by pressure and time. The silence could be protection, a way of keeping those memories safe, sealed away until someone returns to find them. That's what science does in a way. It listens to the quiet things. It reads the silence of ancient light, ancient rocks, ancient chemistry. Venus gives us that same invitation to listen even when we think there's nothing to hear. And so we keep listening. Every new mission planned for Venus carries better instruments, more sensitive sensors designed to detect even the faintest variations in heat, in radio waves, in magnetic fields. We're learning to read its silence as data, to understand that stillness has texture. The planet doesn't shout, it whispers. Its story is there for anyone patient enough to hear it through the static. Even in myth, Venus was never truly silent. It was the goddess of love, of desire, of connection. Its light has always symbolized something alive, something intimate. Maybe that's why its silence feels so loud to us now. We expect something that beautiful to speak, to sing, to reveal. Instead, it reflects light and keeps its secrets. The more we learn about it, the more we realize how much it withholds. But maybe withholding is its way of speaking, of reminding us that not everything must reveal itself to be real. There's a kind of peace in that realization. The sister planet doesn't compete for attention. It doesn't call out or change shape or display its wonders openly. It just shines every night and every morning perfectly consistent. The same brightness that once guided travelers thousands of years ago still appears in the same place, following the same rhythm. That's its form of communication. Not sound, but reliability. The silence of the sister planet is steady, trustworthy, ancient. It tells us that continuity is a kind of language too. When you stand outside and see Venus rising above the horizon, you're seeing that silence made visible. Its glow is the soft echo of its surface heat, of sunlight scattered through clouds, of memory reflected through time. That light travels through millions of kilom of vacuum, reaches Earth's atmosphere, filters through our air, and lands on your eyes. You're not just seeing a planet. You're seeing a message written in stillness. The silence of Venus becomes part of your perception, filling the gaps between thought and wonder. It's possible that our fascination with Venus comes from that silence itself. We're drawn to what doesn't answer. A planet like Mars invites conversation. We send rovers. We listen for signals. We find familiar landscapes. Venus resists us. It allows only brief visits, brief glimpses before swallowing our machines in heat. Its silence is not rejection. It's distance. It's the difference between intimacy and mystery. We love what we can't quite reach. That distance gives the planet a kind of dignity. It doesn't need to prove its value or its past. Its silence is self-contained, complete. It holds within it the weight of all that came before. The oceans, the clouds, the possible civilizations, the long unraveling, the migration of everything that once was. All of it condensed into this one steady presence in the sky. The sister planet doesn't need to speak, because its very existence is the message. That message, if we could translate it, might be simple. Endurance without expectation. And perhaps that's what we're really learning from Venus. Not just about climate or chemistry, but about stillness itself. To exist without needing to be understood. To remain luminous even after everything else is gone. to accept that silence can hold entire histories, entire civilizations, entire lives without revealing them. The planet teaches patience, not through words but through example. If someday we send humans there, floating in the cooler layers above the surface, they'll experience that silence directly. They'll hear it through the soft hum of their equipment, through the steady vibration of the wind around them. They'll look down through the haze and see no landmarks, no horizon, only an endless glow. They'll know they are suspended above a world that has been quiet for billions of years. And for a moment, they might feel something like awe. Not fear, not loneliness, or the realization that even silence can be alive. That feeling might be the truest connection we can ever have with our sister planet. Not conversation, but reflection. Not answers, but understanding. The same silence that surrounds Venus surrounds us too. On every side, stretching between stars, filling the spaces between every atom. We live within it just as she does. We only forget because we've learned to cover it with noise. But in the quiet moments when the world sleeps, when the air is still, when you look up and see that steady light, you can feel it again. The silence of the sister planet is the silence of the universe itself, patient, eternal waiting. And somewhere inside that silence, faintly and endlessly, the story continues, not ending but transforming, carrying us forward to the final reflection. The light that remains after every voice is faded. The glow that outlives both memory and time, the endless brightness of what endures. The sun that warms Earth today is the same one that once warmed Venus. It's the same light that rose over its vanished seas. The same energy that touched both worlds when they were young before one turned blue and the other turned gold. That light doesn't choose. It shines on everything without preference, without memory, constant and impartial. Yet the worlds it touches interpret it differently. On Earth, sunlight feels gentle, nurturing, filtered through clouds that balance warmth and coolness. On Venus, the same light became too much. An embrace that lingered until it burned. And still, even after all this time, they share it. The two worlds, so different now, remain forever beneath the same sun. If you could watch the solar system from a distance, you would see the connection easily. The light spreads outward like a slow pulse, touching one planet after another, each responding in its own way. Mercury blazes. Mars reflects faintly. Earth breathes it in and returns it in color. Venus catches it and glows so fiercely that it outshines all the rest. The same energy, the same origin expressed through different destinies. That sameness is what binds them. Beneath the differences in temperature and chemistry, there's the shared inheritance of light. The quiet proof that they came from the same beginning. It's easy to forget that sunlight is ancient. The photons that strike your skin began their journey at the sun's core thousands of years ago. They were born from the fusion of hydrogen into helium, a process that's been happening for billions of years and will continue for billions more. Those photons spent ages colliding, scattering, and drifting outward until they finally escaped into space. 8 minutes later, they reach Earth, warm the oceans, and make the air shimmer. The same journey happens to the light that reaches Venus, though it arrives just a little stronger, just enough to have made all the difference. The margin between habitability and ruin is measured not in distance, but in energy. Venus once used that same light the way we do, through reflection, through warmth, through balance. When it still had oceans, the sunlight danced across the water, reflected back into space and balanced the planet's heat. The clouds softened the glare, spreading it evenly just as Earth clouds do now. For a long time, that balance held. But as the sun brightened and the air thickened, the light that once sustained life began to accumulate. The balance tipped. The same sunlight that had once nurtured the planet became the force that ended its calm. It's not cruelty. It's simply the way energy behaves. Light gives and light takes away depending on how it's received. That's the quiet truth that connects every world. Sunlight is both origin and outcome. It drives every process, every reaction, every possibility of life. It can also unmake them, not by malice but by consistency. The sun changes slowly, its brightness increasing fraction by fraction until a world that once basked comfortably begins to overheat. Venus was the first to reach that threshold. Earth will one day follow. Mars may never reach it. The difference is timing. Everything that lives does so within an interval, a window in which the light is just right. Venus had its window. It closed long ago, but the warmth remains locked into its air. When we look toward Venus from here, we see that warmth return to us as brightness. The light that left the sun, passed through its clouds, and reflected back into space now reaches our eyes. It's the same sunlight shared and recycled. Every morning when Venus appears in the sky, we see not its surface, not its storms, but its relationship to the sun. A mirror of how light behaves when it meets resistance. The clouds scatter it, soften it, turn it golden. The glow we admire is sunlight shaped by loss. But maybe that's the most beautiful part of it. That even destruction, when filtered through time, can become luminous. Venus doesn't hide from the light that changed it. It reflects it with perfect brilliance. It shows that transformation doesn't erase beauty. It only alters its form. The same sunlight that once boiled its oceans now makes it shine across our nights. It is still under the same sun, just as we are still participating in the same cosmic rhythm. If you imagine standing on Earth and watching Venus rise at dawn, you're seeing the geometry of connection in motion. The sunlight moves from the star to Venus, from Venus to your eyes. And then within your own body, that light becomes sensation. A chain of cause and effect stretching across millions of kilom, linking matter and thought. The sun doesn't distinguish between worlds. It illuminates them all equally. It's up to each world to decide how to use that gift. For Earth, the sunlight became balance. Oceans that regulate heat, clouds that protect, plants that capture and release energy, and cycles that sustain everything. For Venus, the same sunlight became memory, a reminder written in its atmosphere of how fragile equilibrium can be. One world thrives, one endures, both reflect. When you see Venus shining in the twilight, you're seeing sunlight that could have been ours, scattered by a different atmosphere, shaped by different fate. In that light, we see both contrast and kinship. The connection goes deeper than light. The two worlds also share gravity, tides, and magnetic influence. The sun pulls on both in the same rhythm, setting their orbits, keeping them locked in the same celestial choreography. Each sunrise and sunset here corresponds to a motion there. The same star that defines our seasons defines theirs. Even though the experience is entirely different, for Venus, a single day lasts longer than its year. The sun rises and sets only once every 2 orbits, crawling across the sky so slowly that time itself seems to pause. The sunlight there is not fleeting, but eternal. To live under it would be to live in the long, soft glow between beginnings and endings. Perhaps that's part of why Venus feels familiar and alien at once. It shares our sun, our structure, our origin, but not our pace. Its time is stretched. It's like constant. If a being ever stood there and looked up, they would not see day and night as we do. They would know only the gradual drift of brightness, the slow dance of illumination that never ends. It would have shaped their minds differently, their sense of rhythm, their understanding of change. On Earth, we measure life in cycles. On Venus, it would have been measured in gradients. The same sunlight creating 2 entirely different experiences of existence. The thought makes the connection more intimate. This sun that unites us is also the force that differentiates us. It's the common origin that guarantees individuality. Without it, there would be no Venus, no Earth, no contrast between them. Every difference between their worlds is a story about light. How it was absorbed, how it was reflected, how it was transformed. In that way, the sun is the true author of both their histories. It wrote the first lines in the heat of their birth, and will write the last lines when both are gone. And still, in between those 2 points, the light keeps flowing, indifferent but generous. It gives us warmth, drives our weather, makes our food, and paints the sky. It makes Venus shimmer beside us, close enough to touch in the imagination. Every sunset you've ever seen includes light that has touched it. Every morning glow is colored by the same star that brightened its clouds. Even now, while you sit beneath that sunlight, Venus is reflecting it back toward you. Unseen, constant, intertwined. If there's a lesson hidden in that connection, it might be that separation is never total. Every world remains part of a larger conversation. The sunlight that binds us doesn't recognize boundaries. It moves freely, sharing energy between planets, mixing their stories together in ways we can't fully trace. In that sense, when we study Venus, we are studying ourselves. The shared consequence of light interacting with matter. It's tempting to wonder if Venus ever had its own kind of sunlight, its own perception of what we now feel every day. Maybe its creatures, if they existed, saw their sun not as comfort, but as awe, something too vast to comprehend, too powerful to approach. Perhaps they watched the long, slow drift of its light across the horizon and built their understanding of time around it. Maybe they worshipped it. Maybe they feared it. Maybe they loved it in the same way we do, as both giver and destroyer. The same sun, different meaning, the same warmth, different story. What's remarkable is how much of that story still exists here, carried by reflection and imagination. We've built telescopes to study that light, sent machines to taste its filtered heat, written equations to describe its behavior. But beneath all of that, we are drawn to Venus not for data, but for resonance. It is familiar in the way something half-remembered is familiar. We see in it what we might become, and perhaps what we once were. It's not the silence or the heat that calls to us, but the recognition that under the same sun, we share the same origin, the same fate, the same brilliance. Every civilization that has looked up has seen Venus in the same place, bright at dusk or dawn, following the same pattern, repeating endlessly. That repetition is its own kind of comfort. It's the universe reminding us that some things persist even as everything else changes. The continents move, the climate shifts, species rise and fall. But the morning star remains. Its light is the same light that once shone over ancient oceans, over fields of ice, over early fires built by human hands. That continuity ties us not only to Venus, but to every era of ourselves. If you think of all the times humans have looked at Venus, every sailor at sea, every farmer before dawn, every poet or astronomer or dreamer, you realize that its light has touched every life in some way. It's a shared reference, a shared memory. Generations that never met still looked at the same brightness and felt the same quiet pull. The connection is more than scientific. It's emotional. To see Venus is to remember that we are not alone in orbit. That another world moves with us under the same sun, reflecting the same light in a different voice. Even now, when we point telescopes at it and measure its spectrum, we are listening to that voice. The data is just light translated into numbers. The color of clouds, the heat of the air, the reflection of the sun. Every measurement is a conversation between us and it between now and then. The same light that once ended its oceans now helps us understand ours. The connection becomes circular. We use sunlight to learn about sunlight, to understand what it does to worlds like ours. Venus in silence continues to teach through reflection. If you stand beneath a clear sky just before dawn and see Venus shining above the horizon, you can feel the weight of that continuity. The air around you, the warmth on your skin, the light in your eyes, all of the same energy that links both worlds. For a moment, there is no separation. The space between planets feels less like distance and more like pause. You and that distant sphere exist in the same beam of light, the same geometry of warmth. That realization is quiet but profound. The universe is not divided, only unfolded. And as the sun rises, washing the stars away one by one, Venus fades, not because it's gone, but because the light has become too strong to see its reflection. It disappears into the brightness it helped create, hidden in the glare of its parent star. Yet it's still there, moving in rhythm, turning slowly, reflecting faithfully. Its absence from view is just another form of presence. The same light that blinds us from it is the light that keeps it shining. That is the truth of all things under the same sun. They are never lost, only transformed, only waiting behind brightness, only existing in a different register of visibility. The same could be said for memory, for history, for existence itself. We live in one layer of the sun's story, while other layers remain hidden, moving at their own pace, waiting to be seen again. Venus is one of those layers, a reminder that everything we see is only part of a continuum, and that even the worlds that seem most distant are still lit by the same source. When the night returns and Venus reappears in the twilight sky, it feels like a reunion. The light is the same, but the perspective has changed. The planet that once vanished in brightness comes back steady and radiant, as if to remind us that every disappearance is temporary. Under the same sun, everything returns in some form. Every particle of light that leaves the star eventually finds something to touch, something to illuminate. Even the silence of the sister planet is filled with it. So the story continues not in darkness or in light, but in the space between them. The endless rhythm of illumination and shadow, warmth and stillness, life and memory. Both worlds still turn, both still shine, both still share the same sun. And in that shared light, their stories remain intertwined, neither forgotten nor finished, glowing quietly together in the long, patient continuity of time.